Yeah.
So good afternoon, everyone. Thank you for joining us for the webinar on risk assessment of cultural heritage. I welcome all of you on behalf of our team at Masters in Conservation and Regeneration, Faculty of Architecture, SEPT University, as well as Center for Heritage Conservation, CHC at SEPT University. I would like to welcome all our speakers for today's webinar, Mr. Tiago Ferreira, Mr. Arun Menon, Mr. Rohit Jigyasu, and Ms. Poonam Verma. Thank you for your valuable time. We also have Ms. Ashna Patel for the concluding notes. Once again, I would like to welcome all of you. So before commencing the webinar, I would like to convey a few basic instructions to the participants. We request you to use appropriate names. Please refrain from using any casual names on Zoom. Also, keep your videos and audios off for the entire duration. So the format is such that each speaker shall be presenting for approximately 45 minutes, which will be followed by 15 minutes of question and discussion. The participants can type their questions in the chat box for Zoom participants. And for the ones who have joined using YouTube Live, you can type in the comment section. Since we are tight on time, we would be taking up only 5 to 6 or 4 to 5 selected questions as per presentation. So each presentation, 4 to 5 questions. Now, without delaying much, I would like to request Dr. Jigna Desai, our program chair at Masters in Conservation and Regeneration at SEPT University, and also executive director at Center for Heritage Conservation, to give opening notes. Over to you, ma'am.
Thank you very much, Nigar. I won't take much time. I think everybody is here to listen to the other experts. But I'll just start with a very big thank you for Professor Tiago, Arun, Rohit, and Poonam for agreeing to be here together for this webinar. I feel that this particular situation, I am just wondering, why did we not think of doing webinars regardless of the situation, because it really brings in experts from various geographic regions together for us to explore certain subjects that we otherwise that don't become part of mainstream teaching, or even if they do become, we are not able to bring in such diverse perspective on it on a single platform. So I would actually start with thanking Arun for suggesting, I think in one of our earlier meetings, to introduce this discussion on risk assessment as a part of our curriculum, and going deeper than what we were otherwise going in. So I think this is one of our we are going to use this format of webinar to dive deeper into a subject that we think needs that attention. So I think we on behalf of the center, on behalf of the program, I would thank everybody, all the experts, for joining in. Also, I think students have to be here, so I'm not going to specifically thank you, but thank you for being on time, and thank you for I'm sure you'll be very active in your participation. So thanking you in advance, and for everybody who has registered and have joined in this webinar. Thank you very much for doing so. We hope that we are able to contribute something to your already existing understanding on the subject. So yeah, I think I would just say that much. And once again, welcome everyone. Thank you. And I'll before I move on, I thank the team of MCR and SEPT, Ashna and Nigar specifically, and the rest, everybody who's around, who has been extremely supportive. I'm sure Ashna will include all their names when she thanks everyone at the end. So I think, yeah, that's all I'll have to say. And I think over to you, Nigar.
Thank you so much, ma'am, for kickstarting the webinar. So I would like to introduce our keynote speaker, Tiago Miguel Ferreira. He holds a postgraduate degree in rehabilitation of built heritage from the Faculty of Engineering of the University of Porto, Portugal, and a PhD in civil engineering from University of Aveiro. He is currently an assistant researcher at the Institute of Science and Innovation for Biosustainability at the University of Minho and an assistant professor at University of Coimbra, where he teaches in the fields of rehabilitation and seismic retrofit of masonry structure. He is the editor-in-chief of Conservar Patrimonio, a Scopus and a Web of Science index journal dedicated to heritage studies, and co-editor-in-chief of Geohazards, a multidisciplinary journal devoted to the study of geomorphological hazards. Over the last decade, he has been researching the field of urban risk-related issues, namely on the assessment and mitigation of single and multi-hazard risks in urban areas. He has authored several scientific and technical publications in leading internal journals. Over to you, sir. We are looking forward to your speech.
Thank you very much for this introduction. So let me start sharing my screen. Okay, so can you see it properly?
Yes.
Yeah? Okay.
Yeah.
Okay, thank you so much. Just try to drag this thing. Okay, so first of all, I would like, of course, to thank for having me for this very kind invitation. It's a great pleasure to be here today, sharing a little of my knowledge on this very important and very interesting topic. I will basically show you and try to give you some insight on the specific aspects related with the assessment and managing of earthquake, fire, and flood risk in these urban areas. So the first question, and start moving to the presentation, when we talk about this topic, is why, of course, it is important to assess and manage risk in historic urban areas. So we can, of course, say a lot of this, but first of all, because by definition, these historic urban areas are highly vulnerable to natural hazards. And in great part because the buildings themselves, for their characteristics, for their materials, are physically vulnerable to these actions. So then, of course, as they are vulnerable, the consequences that can result from the impact of these hazards are very important, namely human and economic losses may be very significant. And because of this, of course, we should assess and we should try to understand these fragilities in order to mitigate them. And also, because of course, tourism, because of identity, because they're significant to societies, it is supposed that as engineers, as professionals, try to make them last forever or try to make them pass to future generations. So this is also part of our responsibility as professionals and at last extent as human beings. And also because of sustainability issues. So throw buildings away from the point of view of use of resources and the economy is not the best approach. So in many cases, we have to maintain and try to extend the life of these buildings as much as possible. So this aspect nowadays is also very important. Of course, the challenge is huge. So as we know, in the last decades, the level of risk in urban areas has been increasing rapidly due to several factors. That probably the most important are the climate change related issues. Land use is also very important. And moreover, as we are aware of it, so people are moving to cities, and this unstoppable movement is increasing significantly the exposure of these areas to natural hazards. And the thing is that this is tending to increase. According to the United Nations, half of the global population already lives in cities. And by 2050, 2/3 of the world's population are expected to live in urban areas. So this means that this level of exposure is increasing very rapidly and is increasing in a very important amount. So going into the definition of risk, so you may find in the literature a lot of definitions also related with the type of hazards that you are assessing. But in the most simple one, the risk is basically a multiplication, a probabilistic correlation of three aspects: the hazard, the vulnerability, and the exposure. And in this multiplication or in this formulation, the building vulnerability is particularly relevant, not only because of what I said before about the physical consequences of the disasters, but also because vulnerability is where we as architects, as engineers, as professionals can really intervene in order to reduce the level of the vulnerability and consequently to the level of exposure and the level of physical damage and the losses. So even when I have, for example, a bit more hazard or a bit more exposure, if I can reduce the vulnerability, hopefully I can reduce the level of risk. And this is basically the point of my presentation today. So a most important aspect before going into the assessment itself is the scale and is the way how we process data. So nowadays we have a lot of approaches, a lot of methodologies that we can use to assess specific assets. And the way or the right method to use is obviously related with the scale of the assessment. So of course I cannot, if the idea is, for example, to develop fragility curves to the whole world or to a specific country, of course I cannot use the same very detailed methodology that I use, for example, to assess a building. Okay, so there's no sense or on trying to use, for example, an advanced numerical model if I want to evaluate the physical vulnerability of a city, because the amount of data and the computational effort would be impossible to manage. So the first aspect is to decide in which scale I'm working with and the type of method that I should use. And when the idea and when the objective is to assess the vulnerability and risk in historic urban areas, typically more simple approaches are much more efficient than very detailed ones. So how can I, or typically how we manage the data, how we collect and how we work with this data. So typically data on field in historic centers is collected on site, for example, using very simple checklists on paper that basically we go to the street and we start filling out these checklists, okay? And when we come back to the office, basically, I have to transfer this data into a database, and this database can be something a bit more complex in an Access file, or something as simple as an Excel spreadsheet with all the data related with the physical vulnerability of the buildings. And then As you might understand, we are talking about some hundreds or some thousands of buildings, so the amount of data is absolutely massive. So I have to have a way of managing, analyzing, and presenting this information, this data. And probably the best tools to do that is using the geographic information system. So I suppose at least some of you have already learned about these tools. This is basically software that allow us to join databases with vectorized georeferenced information. So basically these maps that we are very used to see, for example, in the news, with different colors related, for example, with levels of exposure, are produced in geographic information systems. So just to give you some more insight about this traditional inspection checklists that we have been using widely in several cases, a real example of a checklist developed in our advanced master in structural analysis of monuments and historical constructions. So basically, we have here 3 checklists organized in terms of the specific aspects related with the physical fragility of the buildings. For example, the configuration and geometrical features of the buildings, the type and geometry of the facades, and the constitution of my floors, my roofing system. So as you can see, this is something very simple, something that should be very straightforward, so that on site I can fulfill these checklists as quick as possible. So of course, things are developing very fast, and we have now new, more efficient, more effective tools, very exciting tools that we can use, and that allow us, help us a lot on these works. For example, Google Street View and Google Maps is an excellent tool, both in pre-processing data before going on site, and also to post-processing data. So we can, for example, before going to the site, we can look for the buildings. We can start collecting some general data about the buildings, for example. So we can save a lot of time with this. Also, this cloud-based data collection solution. So we are now starting using this massively in our case studies, and replacing the traditional checklists that I showed you before with these cloud-based solutions allow you to save a lot of time, because you are basically working directly within your geographic information system. So you don't need to go to your office and to basically move your data from the checklists to an Excel spreadsheet and then to your geographic information system. You do it automatically on site. And also, these photography-based techniques. So this is excellent tools, for example, to map damages, also to create our digital twins, these very exciting BIM technologies. So nowadays, with a drone, not that expensive drone, you can collect a lot of data, very accurate data, and you can create your three-dimensional models. So this is something that is evaluating very, very fast, and this is very exciting. So talking about a bit the seismic vulnerability, how we can perform a vulnerability assessment at this scale. So basically, the general formulation of this type of approaches follow these 3 basic steps. First of all, we have to define the level of hazard which my study area is exposed to. And typically for us, the hazard is basically a discrete value, okay? So we don't perform any kind of probabilistic analysis of the hazard. We simply assume that this specific area, based on its history, may be, for example, exposed to earthquakes of a specific intensity, of a specific PGA. And then basically we relate this hazard with the physical vulnerability of the buildings. And as I will try to show you in the next minutes, we do this with these fragility functions. And fragility functions are basically a function that give you in function based on the specific aspects of the buildings, give you some insight on the behavior, on the performance of the building for that specific hazard. And when you know the vulnerability, basically we can run some probabilistic analysis and start computing the probabilities of having losses. And here we are talking about economic losses, human losses, and for example, the probability of having homelessness. So in terms of structure, these methods are most of the times parametric approaches. So this means that what I do is to assess individually a set of specific parameters that are related with particular aspects of the building. So in this specific case, for this method, I have 4 groups of parameters. The first group regards with the structural building system. The second group about the regularities of and interaction. The third group about floor slabs and roofs, and the fourth about the conservation stats and the elements. And as you can see here in this table, for each parameter, I have vulnerability classes and I have a weight. So basically, these vulnerability classes are a kind of options. So this means that, for example, if I assign for a specific building a class A related with the type of the resisting system, this means that this building is a better resisting system that another building for which I assign, for example, class D, okay? So this is basically how the vulnerability classes work. And then the weights is basically a way of saying that parameters with higher weights are more important in terms of global behavior or to the global behavior of the building than those parameters with lower A's. So in the end, what I can get with this is basically a numerical value, an index that range typically from 0 to 100, and that give you an idea of the level of vulnerability of the building. Again, higher values represent more vulnerability, lower values less vulnerability. So some of these parameters are qualitative, some others are quantitative. So this is an example of a qualitative parameter. Basically, I define the vulnerability class in function of the presence of these very simple elements that have a positive impact on the vulnerability of the building. And this parameter 3, for example, is an example of a more quantitative parameter. In this case, basically what we do is to reduce the building to an equivalent wall and compute the shear strength of this wall. In this way, I can have a good idea of the performance of the building for each direction of the action. So in terms of results, the first one and the most basic one is a map like this, when I have basically my buildings. So each one of these polygons represents a building, and where I can show the level of vulnerability, these IV values for each one of these buildings. So as you can see here, with these maps, I can have, first of all, a very good idea of the overall level of vulnerability of my study area, and also the buildings that are more vulnerable. And of course, these buildings are those that should be our priority in terms of, of intervention, of retrofit, and also, for example, the areas, the urban areas that are more vulnerable. So have in mind that the great objective of these, or goal of these methods, or on these maps, is to provide decision makers with some information based on which they can take some more informed decisions. So this index is interesting, but is just a value, and what can give you is an idea. Things start become more interesting, or a bit more interesting, when you can convert these values into estimations of damage, when you can build these damage scenarios. So what I can see here is a map of a damage scenario for a specific intensity, in this case for an intensity of 8. So this is the level of damage that I should expect if this urban area, if my buildings are subjected to an earthquake with intensity 8. So this is performed in a very simple way, basically using these analytical damage expressions. When you basically input your index value here in this V, when you input your intensity, again, this is just a number, and then a ductility factor that relates with the capacity of your building to dissipate energy. So in this specific case, as you can see, this is for this real case study in Portugal. This is a small city in the center of Portugal, Leiria. And you can see for an intensity 8, it is expected to have level of damages ranging from heavy to distraction. And when I have this idea of the level of damage that my buildings can suffer, I can do some probabilistic analysis, and I can start computing probabilities, and I can have, further than simple fragility curves, those that we are more used to, we can also have, for example, curves that give you the probability of collapse for these buildings. And this is what you can see on this on the top, on the left-hand side. And also the probability of these buildings became unusable. Okay, and again, you can, for example, using the geographic information system, these maps, you can plot some of these outputs together. And when you plot it together, basically, you can have even a bit more insight on our results. So here, what you have in the polygons, in these colors, is basically the probability of unusability and the probability of collapse. But of course, you can put, for example, in your centroids, the number of people that you have inside your buildings and below the probability of collapse. So playing a bit around with these outputs, you can extract very useful and very important information. You can also compute, for example, the probability of casualties and probability of homelessness. And this is very important if you think a bit about it for civil protection purposes. So it is not the same in terms of organization. If I know that I have to find a place to move 10 people or 1,000 people. So this information beforehand, the events, are something very valuable. And of course, if I know the number of people that I have in my buildings, I can compute the number, the discrete number of people that will, for example, perish in the sequence of events with specific intensities, and the number of people that will become homeless in the sequence of these events. And if I know the value of the buildings, and if I know the cost of repairing these buildings, I can also compute economic losses, and I can also estimate my economic losses from these events. So all this is interesting, but what really matters in the end of the day, as I start by saying in this lecture, is to have the capacity, the ability to provide some recommendations in terms of risk reduction strategies and in terms of retrofit. And these approaches can be also very efficient in doing so. So if you know, for example, the level of damage that is expected for each specific building, and if you define a level of maximum admissible damage, what you can do is basically to select the buildings that should represent your priority and start retrofitting these buildings, so that in the end you have your maximum admissible damage as the actual maximum damage in your area. So a very simple example of what you can do following this approach. So basically we have defined two retrofitting package that we call RP1 and RP2. So these are basically these retrofitting packages include simple seismic strengthening techniques, basically aimed at improving the connections and increasing the stiffness of the flooring system in this RP1 with an estimated cost of 35 euros per square meter. And in this retrofitting package 2 is heavier one, also costly one with 185 euros per square meter, and that includes the masonry consolidation and the strengthening of the walls. So basically you have your initial scenario that I showed you before for an area. This is BR before retrofit, and again the level of damage range for between heavy and distraction. And when you, for example, analytically apply this RP1, this simple technique that basically involves and stiffening the floors, you can reduce significantly the level of damages. So in this hypothetical scenario, when applying this technique, you have no more buildings with distraction. So basically you eliminate the distraction, and now your level of damage range between heavy and very heavy. And in this case, 21 buildings exceed mean damage grades 3 for this intensity 8. And when you apply this retrofitting package 2, you can reduce even further the damages and have your own study area in a level that you defined previously as acceptable. In this case, heavy damage. So no buildings exceed mean damage grade 3. I mean, heavy damage for this specific intensity. But of course, you can do what you want with this. You can apply more techniques. You can also define more demanding requirements, and, for example, be sure that you have no buildings in heavy damage and everyone will be in moderate damage. And you can also analyze the differences in terms of losses that you have when applying these retrofitting packages. So this is what you can see in terms of probability of of collapse and probability of unusable buildings. So as I said, no collapsed buildings after retrofitting for intensity 8, and the maximum effectiveness of these retrofitting techniques were found obviously for higher intensities. So often is very interesting to do this kind of comparisons. Also, in terms of probability of death and probability of homelessness, of course, we can see that, for example, for the homelessness, the maximum drop of homelessness were observed for intensity 8. So this means that for very high intensities, of course, these techniques tends to be less efficient because the level of demand for the building is too high, so they are not effective anymore. And in terms of also of economic losses, the retrofitting techniques are more efficient for these central intensities, and this can be also be seen very clearly in this cost-benefit analysis. So if we know the amount of money that I have to apply to retrofit my buildings, and if I can estimate the level of economic losses that I have following these earthquakes, I can compute my payback for the specific intensities. And as you can see, for example, for this particular case, we found that for intensity 5 and 6, basically we got a negative balance. So it is more expensive to retrofit these buildings for these intensities that basically accept the damage and repair the buildings. And the maximum savings have been observed for intensities 8 and 9. Another very interesting aspect from this payback analysis is that if you look for these bars, you can save more money when you apply, in this specific case, retrofitting package 2 than when you apply retrofitting package 1. So this means that in most cases, and in this specific case, it works to apply a more costly technique to retrofit the buildings, because if I have an earthquake, probably I will save a lot of money with this approach. So with these outputs, we can also provide some very interesting indicators in terms of emergency planning, because if I know the level of damage of my buildings, and if I know the probability of collapse of my buildings, I can estimate the possibilities of for example, debris in my evacuation roads, and the probabilities of having some specific urban areas that will be inaccessible in the sequence of the earthquake. And this can be done in a very simple way. Basically, if I define a criteria that, for example, says that a road is considered to be free if the width of this road is higher than 4 meters, and a road is considered to be obstructed or partially obstructed if the free width is lower than 4 meters, and if I have collapse in these areas. So in this illustrative example, for example, what I'm trying to show is that, for example, if I have a collapse of these buildings here, and if I have the collapse of these buildings here, okay, and the free width of this road, or no matter the free width of this road, probably it will be obstructed because I cannot get in because of the deposition of debris in the end or in the beginning of the streets. So following this logic, I can produce these kind of maps. Basically, when I have streets painted in green, yellow, and red, the green is those where I can freely move. The yellow ones are those that probably can go in walking by foot, but I cannot get in using, for example, an emergency car. And the red ones are those that, because of the collapse of the buildings, are the streets where I cannot go without using some more heavy means to disobstruct these roads. And when I know the red roads, I know the areas that will be possibly inaccessible. And this is what I plot here for the city of Coimbra, the 9 areas that following an earthquake of intensity 8 will be most probably inaccessible. And I can also compute the probabilities associated to the inaccessibility of these areas. And also, if I know the number of people that live and that use these buildings in these areas, these red areas, I can also estimate the number of isolated people, the people that will become isolated inside these areas for specific intensities. So following the same idea that I showed before, I can also, of course, try to retrofit these buildings in order to reduce the risk and in order to reduce the number of areas and the configuration of these areas. And this is the exercise that I show you here. So basically, we define 4 buildings. This is my area, the largest one before retrofit. And we identify the buildings that are making this area inaccessible. And if I retrofit these buildings in a very specific and criterious manner, I can reduce the shape of this area from this configuration to this configuration. So, and as you can see, the number of people that I have inside is also reduced significantly, as you can see in this table. So the number of people that are inside this area for the intensity 8 before retrofit is 30 people. And when I retrofit these 4 buildings in an intervention that is not that costly, I can reduce 25% the number of people that is probably stuck inside the area. And now we can also go a bit further, and I can also try to understand the way how people tend to evacuate in case of an earthquake scenario. So we have a lot of tools now, a lot of very interesting models that are basically experimental based, in which the attractive and the repulsive forces that affect the way how people move in case of evacuation are considered. So this takes into account basically the behavioral aspects of the individuals, but also the way how the individual relates with the urban environment and with the other individuals. So this is very exciting and very interesting. You can basically, for specific scenarios, try to estimate and understand the amount of time that people needs to go from a specific point in your area to the safe areas. And you can also evaluate different scenarios, taking into account not only the retrofit of the buildings, but also the location of these safe areas. So this means that if I instruct people that live in these zones and that use these zones, I can tell them, okay, in case of an earthquake, you should run to the right and not to the left, because probably on the right side, the roads are better and the probability of being stuck within the urban area is lower. And this is very, very interesting. So I show you a lot of values, a lot of colors, a lot of hopefully interesting things, but the $1,000,000 question is how accurate and is all this. So this is representative or not of my reality, and this is what matters on the end of the day. And the way of doing this, of making sure that this represents something realistic, is through calibrating properly these methods. And to do that, what I have is to have data about the damages. And if I have data, and if I have enoughly detailed and good data, basically I can do these calibrations in two ways. The first one is to calibrating the weights associated to the specific parameters. And this is an example of doing that for Portugal. So basically we got an earthquake in 1998, we collect data, and then we compare the estimate damage with the real damages, and we redefine the weights in order to get a better approximation between the mythical damage and the real one. And this is the way of calibrating this kind of simplified methods, changing the weights. Another alternative that we have tried with a lot of success last year was to use these self-learning algorithms to not to calibrate the methods, but to calibrate the analytical fragility equations. And we did this using an artificial neural network, when basically in the input layer, we input the IV, the vulnerability, we input the intensity, and in the end, what we have is a new damage obtained with a completely new analytical equation that you can see here. And the level of approximation, the level of accuracy that we can obtain with these kind of self-learning algorithms is amazing. So we can reduce the deviation of about 55% to a deviation of 30%, which is a very good number in terms of approximation for these methods. So in 10 minutes, 5, hopefully, I try to show you also something about fire and about flood. So in terms of methodologies, what we use is something very, very simple. For the specific case of fire, this is also a parametric approach that takes into account factors related with the beginning, the initiation of the fire, with the ignition, with the development and propagation, the evacuation, and also the combat. So in this method, what I can compute is basically a fire risk indicator, similar to that of earthquake, that ranges from 0.6 to 2.0, and somehow I can relate these values with different levels of fire risk. And one example for the historic city center of Guimarães that we performed a couple of years ago. So the challenge was to evaluate almost 500 buildings, and we use this method, and we have obtained this first map with basically the mapping of the fire risk index, and we learned that 6% of my buildings were in low risk, 60% in moderate fire risk, and 34% in high risk. So none of the buildings present extreme risk, which is good. But again, more than trying to take some conclusions from this indicator, it is much more interesting to go into more detail in the specific parameters. So this is what I have here. We can see, for example, the mapping for the risk of fire ignition. And we can see in this specific case that most of the buildings present a low level of fire risk regarding ignition. And this gives you clearly an indication that the problem in terms of fire risk is not related with the ignition, so should be most probably with other aspects. So in terms of ignition, so just to give you an idea, we look for the gas and for the electric installations, for the quality of these installations. It is also very interesting to overlap some of these maps. For example, the map related with the electric installations and the map with the fire risk, and you can see that in some cases there is a direct correlation between these two maps. So, and in this case, this means that this particular aspect is playing an important role on the final risk indicator. We can also look specifically to the fire combat, and again to identify these with red, yellow, and green, these accessible, moderate roads. And again, to for example, overlap, do the second order analysis and combine the fire risk indicator with the level of occupation, which give you also very interesting outcomes. So when you know the risk, you can try to present some risk mitigation strategies. You can follow the exact same approach that I show you for earthquake. Define some intervention packages. They have costs, and you can do some cost-benefit analysis and try to understand how you can mitigate your risk when you apply this money, and also understand the efficiency of these retrofitting approaches. Similarly to flood, so in 2 minutes, just to let you know how we tackle these hazards. So basically, we have developed a method that takes into account the hazard and vulnerability. So typically, in the literature, these flood risk assessment approaches are focused either on hazard or on physical vulnerability. We try to put these two aspects together. Just related in vulnerability, it takes into account the exposure and the sensitivity of the buildings, looking for these parameters or for these aspects. So we can model these hazards. In this case, we have used this ECRAS software, and we can, first of all, have a good idea of the extent of a possible flood for a specific returning period, and understand the number of buildings that in your study area will be eventually affected, and how much they will be affected. You can also compute and estimate velocities at the surface of the buildings and understand which blocks and which buildings will be more affected. And you can also compute the water depth in my area, and again try to understand which will be the buildings that will be subjected to higher flood depth values. And if you know these hazards, and if you know the vulnerability, that again is composed by sensitivity and exposure, you can also analyze these components alone themselves, the vulnerability result. But when you know the hazard and you know the vulnerability, basically you can combine these two aspects, for example, using a metrics-based risk analysis, and you can produce maps like this one with a level of flood risk that takes into account, using these criteria of low, high vulnerability and hazards, you also obtain low, middle, and high levels of flood risk. So just a couple of concluding remarks. I'm extending 2 minutes. So just to say that our built cultural heritage is at increasing risk, as we all know, due to climate change and human action. So these extreme events pose a major challenge, and disaster will for sure continue to occur. So risk management is the key, and the capacity to assess these aspects is fundamental. So digital tools are here to stay, and in a lot of aspects they can give us a lot of help and make everything more efficient and more effective. Regarding these simplified methods, as you see, they have, of course, some uncertainty included because of the scale, but they present and they offer a very interesting compromise between the amount of input data and also the computational effort required to perform this analysis. And they're also very useful, as I try to show, to providing preliminary vulnerability scenarios and pointing the way to define these risk mitigation strategies that in the end of the day is what we want to do. So if you want to know further, I left some references here about papers where all these works are published. You can also reach me by email. You can also see my ResearchGate profile. I have all the publications there, so I will be very happy to reply to your questions. So thank you very much, and sorry again for the extra 5 minutes.
No worries, sir. Thank you so much. Thank you for a very elaborate yet comprehensive keynote speech. And we have a couple of questions for you. One question we have is from Neha Chandel, and she is asking, how was the building material and typology taken into consideration for assessing earthquake vulnerability?
So thank you very much. It's an excellent question, because I cannot went into detail on this, but this is something essential. So the identification of the building typology is actually the second step after defining the scale, because of course we can not have the same amount of detail in our buildings. So for those buildings that we don't know everything about them, we must do this analysis based on the typologies. So the idea is that for each one of the typologies, I try to know as much as I can about the buildings, about the materials, about the construction features of the building. And with this, I will try to extrapolate for the others that I don't know that much. I will try to extrapolate what I know to do some learning decisions. But all these cases that I show in this lecture are masonry buildings, okay? So traditional masonry buildings, stone masonry buildings. And this is the typologies, the main typologies that we work with.
Okay. So were there any wooden, like timber structures also involved? Because I know Guimarães has some timber members and beams and slabs.
Mm-hmm. Yeah. Typically in these buildings, the slabs are in timber, and we also take this into account. Yes, but for I would say for the vertical resisting system is masonry, and the horizontal resisting system is timber. Yeah.
Okay. So we have one more question from Satvika Pancholi, and she asks, How the concepts like authenticity taken into account with retrofitting strengthening measures?
Hmm. Okay. Also, a very good question. So, the idea is always to try to preserve the authenticity of the buildings. This is why the seismic retrofitting techniques that I showed are basically very chirurgic and very simple techniques that, for example, involves um, um, installing some tie rods in the buildings, or simply involve increasing the effectiveness of the connection between these timber slabs and the masonry walls. So yeah, we always try to be as less intrusive as possible in the buildings in order to maintain the authenticity of these assets.
Okay. So I have a couple of questions from me. One is when you were talking about softwares, when where we quantify the qualitative data which we get from these structures or from the type of interventions or sites we are using. So you said that you were using Excel, Access, and of course Beam. So are there any other softwares which are now trending or people have started using or doing research on them?
I mean, at this scale, the softwares are quite simple because we are working with parametric approaches. And for example, the most important software that we use, I would say that is the geographic information systems. Okay, and we can perform all these analyses directly inside the geographic information system, because we are basically talking about sums and multiplications of specific factors and weights. So this is very simple from the methodological point of view. But of course, we can use, for example, more advanced softwares to try to compare and to validate these approach and these approaches. And this is an interesting aspect. Try, for example, to compare advanced numeric analysis, or try to compare more simple analysis based, for example, on macro elements, and try to understand if they fit, the results fit with these more simple elements.
Okay. So one more thing, I was really interested in the possibility of using Google Maps and Google
Mhm.
Views for post processing and pre processing of the data. So are those reliable for when we are using for such accurate and calibrated data?
Yeah, it's very interesting. Two aspects. The first one is that I said that we can use this, for example, to collect some preliminary data that afterwards you need to check and to validate on site. But we can for sure save a lot of time, because you can reduce in a very significant way the field work. But I must say that last year I have supervised the thesis where the idea was just to do a blind test on that. So I had results when I obtained doing the entire framework with on-site, very detailed on-site field work. And I did a blind test with the students. So basically he used Google Maps, they used the methods, and it was very interesting to see that on average the results are very close. Okay, for the specific buildings they are not that closed in terms of the vulnerability that you got for specific buildings were not that closed. But for example, to produce vulnerability curves or fragility curves for these areas, I would say that these may work pretty well. It's very interesting.
Okay. We have one more question from Poonam Verma, one of the other speakers. She asks, so does the Research Generating Institute and governance body work together? Who funds the study and how is the information used by the city government? What role does the city public have?
Also, a very good question. So we always try to work very close with the municipalities, and for example, in these specific cases for Guimarães and for Leiria, we managed to do that. So they provide us a lot of information. They work on site with us. So our problem is always the after. Okay, so how they use this information, these maps, is something much more complex. And unfortunately, my feeling is that sometimes this is forgotten somewhere in the desk of someone in an office. But yeah, at least they are always very interested in understand the fragility and the vulnerability and the risk of these areas, which is good. Uh,
Okay. So we have one last question from Neha Chandel again. Could you throw some light on how RP1 and RP2 can be used in repairing what different kinds of seismic damages?
yeah, interesting. Yeah, so RP1 is basically used to try to prevent the out of plane collapse of the facade, the entire facade, or the partial collapse or the facade. And this is, of course, as I shown, very interesting and very important when we are looking for the evacuation scenarios. And the RP2 is much more, it's a much heavier technique, is basically retrofitted retrofitting the walls using retrofitted plasters, and from the point of view of the preservation of the authenticity is not that interesting. And this is something that we use, for example, in buildings that have very poor masonry walls, and that there's no way of trying to avoid the disaggregation of the walls without retrofitting them. But whenever possible, again, we try to use RP1, that is basically make the connections more effective, make the floors stiffer in order to have a better distribution of the deflections, and try to just use these more compatible techniques.
Yeah. It was a very interesting case where use of RP2 was more advisable than use of RP1 in, I think, case number 6 and 7, right?
Yeah,
So
yeah,
the entire
yes.
process gives you an holistic view that how even the price, even if they are expensive or a cheaper technique, at the end,
Mhm.
it is different for each case and scenario.
Yeah, and in other cases, it was also interesting to see that, for example, uh, RP2 or RP3, the heavier techniques, turned to be less efficient from the economic point of view. I mean, led you to less payback, but you could save much more people applying this technique. And this is also interesting because sometimes this idea of saving people is not compatible with the idea of saving money. So this is a very difficult decision from the point of view of the decision making and the politics.
Yes. We have a similar cluster of houses in Ahmedabad as you had shown in Coimbra. So maybe in future we can implement the exact same technique here for Ahmedabad and see how the mechanism works. Thank you
Yeah.
again, sir. It was a very insightful key speech. And now we'll move forward to our next speaker. Thank you again.
Thank you again. Thank you again for having me.
Thank you. So next we have Mr. Arun Menon. Arun Menon is an associate professor of structural engineering at IIT Madras. He holds a first degree in architecture and PhD in earthquake engineering from University of Pavia, Italy. His research interests are in structural aspects of historical construction, earthquake behavior of historical masonry structures, and earthquake-resistant structural masonry. He currently coordinates the activities of National Center for Safety of Heritage Structures, a Ministry of HRD Government of India supported research center at IIT Madras. He was an expert member on the International Coordinating Committee for the UNESCO World Heritage Site of Bagan, Myanmar, and currently is a member expert advisory group to International Conservation Committee for Wat Phu UNESCO World Heritage Site in Laos, PDR. He has been involved in conservation projects in India, Bhutan, Myanmar, and the Philippines. Arun sir, over to you.
Thank you. Thank you, Nigar. It's a pleasure to be here with all of you at SET and from outside. And I look forward to the interactions after each of the panelists' presentation. I see a lot of familiar faces here. Among the participants, I see Harish, who's worked with us for several years. And of course, Satvika Pancholi, who's also has been working on her thesis related to the subject of today's webinar. Okay, I'll share my screen and then take you through the presentation that I've prepared. The presentation is visible?
Yes, sir.
Yeah. Okay, so yeah, I'm sure Tiago's presentation here has taken all of you through the rigor of risk assessment that's required at historic urban scales, historic cluster scales. In continuation of that, and I think I can really fall back on the kind of introduction that he must have given and the rigor in the work that must have been demonstrated. I would fall back on some Indian contexts that you would be able to relate to, probably even directly to the places where each of you are. So the topic of the presentation that I'm making is disaster risk reduction in built cultural heritage. And I have divided my presentation into these parts: natural disasters and built heritage. That's a constant that we need to keep in mind and keep responding to. I would quickly look at the disaster management, disaster mitigation and management status and built heritage in India, and then examine the different phases that we are really talking of, right from the disaster management phase, post-disaster, then the disaster mitigation exercise, which is typically a pre-disaster exercise that leads to reduction of the risk. In this context, while my work, the work that I engage with is primarily dealing with earthquakes, it's important to look at a multi-hazard scenario due to different potential hazards in a given site. And in that context, I would like to look at a small example of how this could be put together. Of course, today there are several methodologies being developed worldwide, and one needs to examine the applicability of a certain methodology developed and verified on a given location, its transportability to another site, and whether certain changes are required fundamentally or in the details. While we're talking of risk reduction, it's not only at the level of an urban cluster or a cluster not necessarily in an urban area, but also individual buildings. And risk reduction needs to occur finally at the level of individual buildings, which collectively then would lead to the overall risk reduction of a territory, of a cluster, and then of a territory. So I think it'll be useful for us to identify the differences in terms of approach to these two to these two challenges that we have as far as risk reduction is concerned. I think all of us are aware of, I'm speaking to a group of transformed people, so I don't have to overemphasize this, but we know that built heritage, historical buildings, monumental structures, ancient monuments, they actually have augmented vulnerability to natural disasters. And that's evident to all of you. I'm sure many of you are not in Ahmedabad at this point in time, but all of you are definitely aware of the fact that a place like Gujarat is repeatedly affected by earthquakes, significant earthquakes. They might not necessarily be occurring too many times in one's lifetime, but as far as the life of the historical monuments or the heritage structures are concerned, they would see such a disaster more number of times in the lifetime of these buildings. So the Bhuj earthquake is a case in point. This was now 20 years ago, almost 20 years ago. And the district of Kutch itself, if you look at it, which had listed 15,000 heritage properties, had in just one event, which is a few seconds, the entire earthquake record of the Bhuj earthquake is about less than 2 seconds and you less than 2 minutes. And you had about 10,000 heritage structures which were destroyed or extensively damaged, as per the reports of INTAC, which had done the ground level post-earthquake surveys. Now, if you look at our subcontinent and examine all the natural disasters that have been happening, and I'm not counting man-made disasters, you had the Indian Ocean tsunami after that in 2004, you had the Kashmir earthquake in 2005, the Sikkim earthquake in 2011, the floods in Uttarakhand in 2013, the Kashmir floods in 2014, the Nepal earthquake, the massive earthquake, and the kind of effects on the historical structures, the heritage structures, and the tourism industry was massive. The Myanmar earthquake in 2016, and this continues, and this is only going to continue. There is no stopping. And as Thiago had very nicely put it, between the hazard, the vulnerability, the hazard and the vulnerability, it's really the vulnerability that we can work on. The hazard is something that we'll have to learn to live with. So it is important to take cognizance of the different hazards that is there in a given territory. And that's your starting point. The moment you identify all the hazards and you have a way of quantifying the hazards, you already are at a good starting point because you know what you have to be prepared for. And as I said before, I take the example of Gujarat. And if you look at Gujarat, if you look at the Bhuj earthquake, it happened in 2001. But in 1890, one of the largest earthquakes in recent history recorded. And so you're talking of in about 180 years, repeat of an event of similar magnitude and similar catastrophic effects. So the region is repeatedly seeing such events. And while human beings may not see such catastrophic events within their lifetime twice or more, historical monuments, which we expect to last for several hundred years, if not thousands, would be repeatedly subjected to. So if you look at the subcontinent and see these examples, the picture that you see here is of Bagan, which is a World Heritage Site now from 2019. Bagan has become a World Heritage Site, and this is a region which was affected in Myanmar by a massive earthquake in 1975. And now in 2016, so that's about 40 years later, you had another massive earthquake. Very similar, actually it is of lesser magnitude and lesser effects, but it is a repeating phenomenon in this region. And if you actually look at it, the people who had worked in the post-earthquake period after 1975 are still alive and know the kind of efforts that were taken immediately after the 1975 earthquake. And then we're looking at a similar situation several decades later. And in this context, it's a book that I keep referring to whenever I get the opportunity. It's a fantastic book for the concept of earthquake preparedness as far as historical monuments and heritage structures are concerned. And that's this book written by Sir Bernard Fielden called Between Two Earthquakes. It's possibly one book which you don't have to read and just see the title and internalize the point that Sir Bernard Fielden wants to make. And he says in the preface, lessons must be learned continually, and we must always be aware that we live between two earthquakes. And this we live is primarily with respect to historical monuments. We tend to engage with historical monuments between two natural disasters. And that means there must be a cumulative effect of improved knowledge and improved resources to make them, protect them from natural disasters. So this is not only as I said, not only a context as far as Myanmar is concerned, but as I said, Bhuj 1819, 2001, you had the Nepal earthquake recently, but then the big event that happened in the 1900s was the 1934 Bihar Nepal earthquake. And then, as I said, Bagan in 75 and 2016. So this is in the context, in the subcontinent, this is something that we should be aware of. If you look at India itself, and then look at the kind of historical stock that we have, before I get into even unprotected heritage, unlisted heritage, which runs into several tens of thousands, if not more, but the sheer numbers that we look at as far as India is concerned is massive, and that is where we really have to scale up efforts. So you see in front of you the World Heritage Sites in India, and we keep adding every year to this list. Today we stand at 30 cultural sites, 7 natural sites, and 1 mixed site. So we have 38 sites that are there in the country. And what you see is the earthquake zone map. You have zones 2, 3, 4, and 5 of the earthquake code of India, IS 1893 part 1. And the blue zone is the lowest seismic zone today. It may be strange that we're calling it zone 2. That's because we decided to remove zone 1, which was referred to as an aseismic zone, after the Latur-Killary earthquakes actually happened in the aseismic zone. So the scientific community thought that was a zone that's safe from earthquakes, but then you had an earthquake which caused the death of more than 10,000 odd people. And so we decided that there is no region in the country where with today's knowledge, you can actually vouch for being aseismic or without earthquake effects. So we go from zone 2 to zone 5. And zone 5 is, of course, parts of Bhuj and not the northeast, where all the northeastern states would come into that region except Sikkim, and parts of Kashmir, and of course the Andaman and Nicobar Islands. Zone 3 is where I live in, that's Chennai, and Ahmedabad is also in zone 3. And if you take Delhi, it's in zone 4. Now, the point that I'm trying to make with this is about 60% of our World Heritage sites are sitting in moderate to high seismic zones as far as India is concerned. Now, so have we, or has the Archaeological Survey of India launched an exercise to systematically study all of them and understand that are we going to lose some of these in an earthquake or any other natural disaster for that matter, or not? Or are we just working in a disaster management mode where once there is an event, we wake up and then make a lot of noise and then sit back? By the way, it's 20 years after Bhuj, and how prepared are we in cities like Ahmedabad, or the city which is recently declared as the World Heritage Site, a World Heritage City in the old city of Ahmedabad. So there's an interesting directed research project that one of your at CET, one of the second year students is actually working on. So this is an important context that we must realize, that there is a present danger as far as historical monuments are concerned. Do we take cognizance of that, and how do we work towards reduction of that risk? Disaster management, DMM is disaster mitigation and management. So it's actually twin aspects that you must take care of. Disaster mitigation and management, heritage conservation in India. It would be useful to just for a moment look at what are the statutory provisions and the doctrines that we should fall back on for guidance. Of course, you have the entire subtext of the international doctrines of conservation, all the way from the 1964 document of the Venice Charter to the NARA 20+ documents discussing various aspects, including aspects of protection under natural disasters. If you look at the nationally protected monuments, you have the MSR Act, the Ancient Monuments and Archaeological Sites and Remains Act from 1958. And in 2011, you have the National Monuments Authority, which then works in tandem with the Archaeological Survey of India to provide permissions and sanctions where repairs and extensions of structures, new constructions of structures in the space around historical nationally protected monuments are concerned. We have the National Conservation Policy, and this is an interesting policy document that came out in 2014, which and I make reference to two statements or two clauses of the National Conservation Policy. One of them requires, it's a policy document, mind you, so this policy document needs to be further catered to and adhered to in terms of specific rules and regulations and systems in place. So the National Conservation Policy actually requires that the monuments of national importance, which are around 3,590 monuments across the country, they are scientifically assessed and retrofitted. So the policy document expects you to do that. We need to rise up to do that systematically. It also requires that conservation efforts at every monument must be accompanied by a disaster management plan. What would be the way disaster risk reduction is achieved monument by monument is a component of every conservation proposal that must be developed at a site. The same thing extends to the state protected monuments. I'm just giving you an example of Tamil Nadu, which also has such a law, the Tamil Nadu Ancient and Historical Monuments and Archaeological Sites and Remains Act, the MSR Act, but for the state. And of course, you have to look at what the National Disaster Management Authority, through its act of the NDMA Act of 2005, which is actually something that came up after the effects of the Bhuj earthquake, speaks of in terms of historical monuments. So the National Disaster Management Authority actually has a document, which again is a policy document on what should be the guidelines for disaster management and risk reduction as far as cultural heritage sites and precincts are concerned. In fact, there are two documents today. One is this guideline document for heritage sites and precincts, and the second document is on museums, so which I have not listed here. But these are the two documents that touches upon the ambit of disaster management, disaster mitigation, and historical monuments. And that's something you must read through and link to the kind of work that each of you are doing. Okay, so this is the typical cycle that one should be aware of as you're working with a disaster and with any context. It could be the urban setting, it could be modern buildings, it could be any system, it could be building systems, it could be historical systems or whatever. And there's a global understanding that this is what we should be looking at. So you have, I have my favorite word here, earthquake, but it could be any other disaster. So you have the disaster that strikes at a certain point in time. The period immediately that occurs after the disaster is the response period. It's the immediate response period. So in the immediate response period, you would go ahead and do, you would carry out safety evaluations. You might require short-term countermeasures because you don't want these historical structures which have been affected in an earthquake already to fall due to an aftershock. And then you have to come into the recovery period. So in the recovery period is where you start getting into some detailed surveys and measurements, which will then help you move towards repair and retrofit. So the recovery phase is the second phase after an event. You get into repair and retrofit. You might have to do detailed assessment. Initially, you had just done a quick safety evaluation, which may be a form-based evaluation that you're doing. So if you see this, the entire screen is divided into two halves. You have the emergency response and reconstruction phase, and the phase above is the capacity building phase. So which means you go through the response period, the recovery period, and over time, slowly, it may be 5 years, it may be 10 years, get to a phase where you've actually taken care of all the earthquake effects on buildings. You have now repaired and retrofitted, repaired the buildings that were actually damaged, and then you need to get into the mitigation phase. And what's the mitigation phase? You need to identify in other territories or in the same territory, buildings which have not been affected by the previous earthquake, which potentially can get damaged in a future event. And that is where mitigation efforts and disaster risk reduction really comes into the picture. You need to be able to assess and identify which are the vulnerable ones, what should be done to reduce the vulnerability. And as you do that, you're working between the mitigation phase and the preparation phase, and you're preparing for the next event. So this is a cyclic process, and over several cycles, the intention is that the risk is reduced in a given territory, in a given context. So this needs to be kept in mind. So with this background, I will just take you through certain aspects of each of these phases. So immediately after an earthquake, you would, it is difficult to separate these phases and say, I'll work only in a certain phase, or I'll, work only in post-disaster, or not work in mitigation measures. It's very difficult to separate these, and unless you work in all of them, you don't get a feel for what actually should be the process. It should work like a well-oiled machine. So in the post-disaster phase, you need to do assessments, and these assessments are typically at various levels. As I was mentioning, you immediately after an earthquake, you might have to go in and protect a structure so that it is safe against an aftershock. It doesn't come down during an aftershock. And there are several instances world over where buildings have been damaged in the main shock and then collapses in an aftershock, or the aftershock was much larger than the main shock, the first shock, and that was a surprise element. So when you look at assessment post-earthquake, there'll be different levels of rigor, different levels of complexity. So you start with a rapid visual screening, and here it is basically to understand post-event occupancy. Let's say the building is being used for some purposes, or it's a public building. Can you even get into the building? That needs to be decided. So you use a rapid visual screening method to do a post-event occupancy judgment. And then you get into visual damage survey. It will be conceptual because you're trying to understand, look at the damage and see what is actually lost in the building in terms of its capacity against gravity, carrying function, or even future earthquakes. So you look at a relative degree of damage and understand what has happened to the structure. And then you get into simplified quantitative assessment. You want to understand what's the safety margin that's left, or how much of safety margin is compromised. And then before you get into retrofit, repair and retrofit, you do a detailed quantitative assessment where you're looking at the component level deficiencies. You try to understand if a wall has to be repaired and strengthened, or some columns have to be retrofitted, repaired and retrofitted, or foundations have to be addressed. So you look at a component level deficiency and understand how to design your retrofit and rehabilitation. So this is post-earthquake, and as I said, different levels of detailing and rigor that will be required. So typically, if you're looking at the rapid visual survey form, this is an example of a rapid visual survey form which was applied to Bagan immediately after the earthquake. And the reason why we had to develop a form was simply because Bagan itself has about 3,200 monuments that are listed in the archaeological site. So this is, of course, for earthquakes. You would need a customization for different hazards. It could be floods, it could be fire, it could be landslides, or several other possibilities. So you need hazard customization of such forms, and it is always useful to have one form that you can't hunt for a certain form when a specific hazard happens. It will be useful if these forms are conscious of the multi-hazard scenarios that are present in a given territory. And of course, one has to be careful. You can't pull out the reinforced concrete form and go and use it on a historical masonry building, or you're doing a fire assessment of a timber building and you have with you only the steel form. So these are issues that one has to be careful about. The typology customization is important, and hazard customization is also important. I did mention that you have these different levels. You have the post-earthquake rapid assessment. Then you may get into some qualitative detailed assessment with damage mapping. You can then get into detailed assessment, which is quantitative. where you're getting some material, testing it in the laboratory, and so on. And then you get into a rehabilitation strategy and execute and implement so that you have strengthened the building, you've repaired it, you're ready for it to face the next possible disaster as it comes around. So some examples, in the post-event phase, you need some sort of a nodal agency, which is normally the disaster management agency, but it's not necessarily only the disaster management agency. There will be several other entities who take care of this post-event engagement with the site. So you need a nodal agency and you need a network. So it'll be useful for all of you who are taking, all of you who are students of conservation at this stage to understand how in India, the Disaster Management Authority is planned out. You have the National Disaster Management Authority, you have the state disaster management authorities, and then you have the district disaster management authorities. So the nodal agency and their network is important to understand how this period will be tackled and coordinated. We do reconnaissance surveys and do temporary stabilization. This is one example of this sort of an exercise. Dr. Rohit Jigyasu is here, and colleagues from Portugal. We were all involved in Nepal, along with the Department of Archaeology, to work and do some training in the immediate aftermath of the earthquake with the Department of Archaeology. Of course, you cannot start training after the event. And that is the reason why the mitigation phase is so important. The mitigation preparedness phases are important. That is when you're building capacity. You build capacity, you're ready to face the event. You cannot have an earthquake and then start saying we need to start training people. It really doesn't work effectively in such instances, because you have to find the right personnel, you have to give them the right training. It starts becoming difficult. And that's why being conscious of the cycle is extremely important. Having talked about the post-disaster period, the mitigation period is the mitigative exercises in the capacity building period is extremely important. We would call the post-disaster phase as the wartime, and that's just disaster management that is happening. But in the capacity building phase, referred to as the peacetime, you are building capacity. And you need to launch a series of pre-event exercises that builds the necessary resources, systems, and capacities to prepare the context that you're looking at for the next disaster. So what are the pre-event exercises? You develop your risk preparedness. You can do assessments. You can understand and find out which are the structures which may require interventions. You carry out training and capacity building programs. You prepare manuals. You cannot be preparing a manual after an event. You should know when a manual should be prepared. That it should happen in the capacity building phase and not immediately after an earthquake. Of course, any tool that is developed immediately after the earthquake can then be adopted as the manual or adopted as the basis for becoming a manual. But these are things that are typically in the disaster mitigation phase. And as I said, this is where risk assessment programs should come into the picture, because you can't do risk assessment immediately after the disaster. You need to have a calm mind. You need to have methods in place. You need to have systems in place, and you need to look at a multi-hazard scenario. You cannot be looking at in certain territories, specific hazards may dominate. So it is important to respond to those dominating hazards, but it is of course important to keep in mind that there may be other hazards which may not be as recurrent as the main hazard. If you take Venice, for example, if you go and speak about earthquake hazards in Venice, they're going to not consider you seriously, simply because while there may be a low probability of an earthquake effect, it's the rising water from the sea level which is the biggest hazard. So one needs to understand such context from a multi-hazard scenario. You need to look at urban clusters or clusters in even non-urban areas. So you're working with a population of buildings. But you must also remember that you may be working with a population of buildings to do your risk assessment. But finally, you need to work at individual building level. You need to work at individual building level to reduce the risk. So you need to translate at certain point in your strategy from the population of buildings to individual buildings. But then another aspect is when you're looking at monumental buildings, it becomes difficult to deal with monumental buildings in the same manner you would deal with a population of ordinary buildings. Ordinary in the sense even a historic cluster of residential buildings, like the historical urban centers in towns, in cities, you can consider that as a cluster of buildings and deal with it as a population of buildings, and then intervene at the level of the individual building. But specific monuments, it is difficult to deal with specific monuments, historical monuments, at a population of buildings level. You need to do work at the specific monument. You can't take Taj Mahal and study it at the same level as one of the 1,000 buildings in a historic cluster, or for that matter, any other important monument in the country. So this distinction is important. When do you approach vulnerability assessment at individual building level, and when do you approach it as a population of buildings level? And why is this distinction important? When you're dealing with a population of buildings, you accept the fact that you cannot have such a detailed procedure that you're going to take forever to study 1,000 buildings. You need to have simpler methods, and the methods that Thiago was referring to and presented just before is very much in that line, that the methods that you use, the tools that you use, are designed for a large population of buildings, and the rigor is there, but you're able to cover a large number of buildings and arrive at the risk assessment. You cannot use that directly on a big historical monument, and you need to approach that from a detailed assessment point of view. And you can spend a few days to study the historical monument, but you cannot spend several days to study a single unit of a population of buildings. So this distinction is important. Okay, in this context, I'll just give you a small example that we had done. This was completely an academic exercise, and this was not something that was sought from the city municipality, but was a self-driven exercise at IIT Madras. And Harish is here, Harish Haridasan, who's also an alumnus of CEPT, and he was part of this academic exercise that we had done at master's level. It's the master's dissertation work of one of my students by the name Ajinkya Kulkarni. So we kind of attempted to look at a multi-hazard prioritization scheme. And why do you need a prioritization scheme? So when you're looking at a population of buildings, it becomes essential to understand where you need to focus your resources. It becomes important for the city authorities, for the disaster management authorities, for example, to understand where is that the highest vulnerability is, and therefore possibly the highest risk is. And if you focus on those, if you focus on those assets, then you might achieve reduction of risk in a much faster and much greater manner than not knowing where to focus your resources. So the context with which I'm presenting this is prioritization. If I look at a multi-hazard scenario, do I have a prioritization scheme? Can I say which is the element of the context of buildings that I must look at first, and then probably plan over a 10-year period and say, okay, we could cover so many buildings over so many years. So, and I should also mention that there are several methods today available and several teams that are working all over the world on multi-hazard scenarios. And we've just written a research proposal along with, in fact, University of Porto, and hope that this gets considered in the evaluations. It's an interesting project that we proposed on museums across the Portuguese territory and the Indian territory. So Thiago was mentioning how risk basically comes from a convolution of hazard, vulnerability, and exposure. So hazard is the one that is given to you. You have to quantify it, and you should be able to deal with it. You can't reduce the hazard. You can only look at how vulnerable your systems are and reduce the vulnerability. And for buildings, you can retrofit them, you can strengthen them to avoid the potential damage under a given hazard. Exposure comes from the fact that how many such buildings are there which are exposed to a certain hazard, or how long are possibly the contents of a building or the people living in a building exposed to this. For example, if you take a school, your school building is operational for about 8 hours. So it's 8 hours out of 24 that people are physically inside a building, and that's exposure. Compare it to a residential building, 24 hours, people may be staying inside a residential building. So the exposure is more in a residential building and lesser in a school building. So these aspects of hazard exposure, hazard vulnerability and exposure needs to be looked at. And when we work, we try to understand these different aspects of the risk equation. And this is exactly what I had just mentioned. So you can, you should be able to estimate the hazard. You should be able to estimate the damage proneness of the building and understand what is the sort of exposure because of the hazard in terms of people, in terms of the assets, in terms of any other aspects. Now, you could have qualitative approaches, you could have quantitative approaches. There are different approaches world over. And it's become such a interesting, important area that there are several research groups working on it, and it's difficult to find your way through all the publications, all the methods that are coming out of it today. So here we have looked at working on Shimla, and the reason why we chose Shimla is for different reasons. We actually looked at this as a pilot exercise for multi-hazard risk assessment for a historical precinct. We looked at Mall Road in Shimla. Many of you may be familiar with this region. It's in earthquake zone 4. So that's one shot of the highest earthquake zone as per 1893 part 1. So it's earthquake prone. You must have heard of the Kangra earthquake in Himachal of 1905, which was massive destruction in different parts of Himachal. Not as much in Shimla, but they are in the same state. They are, this road itself, which has a whole lot of historical precincts, is located on two sides of a slope, two sides of the slopes of a ridge, and is a region which is landslide prone. There's a lot of use of timber. It's a hill station. It snows here. You have snow loads as well. Of course, snow loads are taken care of in the building designs themselves and the building typology. But because of the amount of timber and the heating that is typically done, fire hazard is another aspect. So we wanted to look at a combination of these hazards, earthquakes, landslides, and fire. So that's Shimla for you. You can see the valley, which is today full of structures. We had to look at these different hazards and collect information on the vulnerability against each hazard. So our intention was to look at a quantitative method by which we are able to prioritize and understand what's the ranking of the set of buildings that we examine. We did make some assumptions, and one has to always carefully look at the assumptions because they can have significant effect on the outcome. We didn't consider secondary hazards, meaning a fire can be triggered by an earthquake, and that's like a secondary hazard. We did not consider an earthquake-triggered fire. So we looked at only a primary hazard like a landslide happening on its own because of rainfall probably, earthquake happening on its own, or fire happening on its own. Of course, the chances of multiple hazards occurring together is low, but chances are low. It can never happen. You look at what is happening today. We have a pandemic, and we live in a very different world. There are a lot of restrictions. Do other disasters happen? Of course, if you look at in the last 7 months, we've had 2 earthquakes that happened. One was in former Czechoslovakia, I think in Slovenia, that we had one earthquake. And yesterday in Turkey, Greece, that region, we had another earthquake. So these events are not going to announce when they're coming. They can happen together. And it's just that you might have just hit that low probability of occurrence and it has happened. So one has to be mentally prepared when such events, such studies or such assessments are being done. What we have really done here is we've looked at independent hazards and their effects, and then we've basically done a summation of, so the net risk is a summation of the earthquake risk, the risk due to landslides, and the risk due to the fire. And what we've basically done is, since it is quantitative, collecting information and then ranking, we've had to define what would be a low risk class, a medium risk class, a high and a very high risk class. And so this is a pilot works. This needs to be verified. This needs to be applied to a larger scale and checked if it is reasonable. So just a little background, I'm not going into the details. For the exposure model, we looked at some empirical scenario-based methods that are there by one of the most prominent names in this area of risk assessment and exposure models, Coburn, and Spence. We basically look at aspects such as population, the occupancy ratio, how many occupants may be trapped due to collapse, what is the injury distribution when an effect of a disaster happens on a building, what is the mortality post-collapse, people may get hospitalized and how many may die out of that. You have statistics that can be used for different earthquakes, different disasters worldwide. We've had to look at the exposure model and then the hazard model. For the hazard model, we've basically gone with the definition of the earthquake hazard in probabilistic terms, and these are available for different territories. I talked about the National Disaster Management Authority. If you go to the website of the National Disaster Management Authority, you have this defined for different territories, up to the level of the city and up to the level of the district. These are detailed. So you have the vulnerability atlas of the country, and you can get the necessary hazard models for different hazards. Landslide hazard, we've looked at modeling this based on average number of landslides that will happen in a year in a given territory. So you sort of get the probability with which this will occur. And fire hazard, we've looked at, you need to have a source of fire. You need to have the source of the fire, which may be electrical short circuit or something of that sort, or lamps. And then you also need to have fuel, because if you don't have fuel, catching fire is not going to be possible, or something that is inflammable is not present, then the fire will not be generated. But the probability of the spark generation and the fuel catching fire is what the fire hazard is looking at. We've looked at, those are the hazard models. You need to have vulnerability models, and there are several vulnerability models because earthquake behavior of buildings is understood worldwide. And therefore, we've looked at some methods from the literature. Example here is the FAMIVE method, where we try and estimate what is the capacity of a structure and whether for the expected earthquake shaking in a given territory, a building will suffer damage. So you were looking at estimating factors of safety and the mechanisms of damage possible using simple form-based methods. Landslide vulnerability, you've looked at slope stability methodology, and then other aspects that then tell you if the vulnerability is higher or lower. For example, vegetation, the frequency of these landslides, saturation of the soil, the strength, the angle, shear angle, the drainage of the site and the usage, whether there are buildings, is it plain, and so on. And for fire vulnerability, we've looked at a fire safety evaluation score methodology, and you can then attribute different scores and weightages and arrive at what is a fire safety score for a given building. So as I said, we've looked at existing hazard maps. So the vulnerability atlas of India from the Geological Survey of India and the BMTPC, the Building Materials and Technology Promotion Council of India, have these vulnerability atlases that are developed. So you have the earthquake hazard map, you see the different zones, you have it for Shimla, you have the earthquake map of Shimla, and the level of expected earthquake shaking is mapped and given to you. So you're looking at Mall Road, and we're interested to see how much of earthquake effect is going to be there. Similarly, the landslide hazard map, again for Himachal and the region that we're looking at, high vulnerability, high landslide prone zones and low landslide zones and so on. Forest fires, because we want to know if forest fires can reach the cluster of buildings that you're looking at. Of course, those of you who know Shimla, this is a region where there's not much vegetation, and so forest fires is really not an issue. More probable is a fire getting triggered in the building itself. So this is the forest fire hazard map, which you can again get from the vulnerability atlas. And then you need all these, you need to have forms that collect information, because it's based on this information that you're doing the weighting and the scoring. So these are some forms. This is the form which has multiple parts to it. You get general site details, landslide proneness details are recorded, Then there are portions which are recording the earthquake vulnerability details. Then you have the portion that is dealing with the fire safety details. So a form can actually be used by going around the building and spending about 30 minutes to 45 minutes per building. So that's the amount of time that you're really looking at for a rapid visual survey. And then go compile your data and start looking at what the data is telling you in terms of the vulnerability of the system. So what we did is we looked at about, on Mall Road, we selected about 20 odd buildings, about 24 buildings here, not a large number, but it's a pilot exercise, mind you. And you have the data compilation here, the geometry data, the typology, and other important features which can be triggers for specific damage. I'm just showing you a summary of the final result, in fact, and then have a little discussion on that. So we looked at, we had our scales, the numerical scales to be able to understand if you're looking at low, medium, high, or very high earthquake, landslide, or fire risk. So this process led us to classifying. It's a small number, 24, and out of that, we were looking at how many have low, medium, high, or very high earthquake risk, landslide risk. Of course, landslide, the site is important. Certain locations may be safe from landslides, certain locations may not be safe from landslides. And then you have the fire risk. Then, as I said, you're looking at arriving at a net risk, which is basically a summation of all these risks, so that you kind of understand where is that you must focus your resources first. So if you look at the total risk, there are as much as about 50% lying in the high vulnerability, the high risk zone, and about 30%, less than 30% in the very high risk zone. So this sort of gives you some directions on where you want to focus your resources, both time and financial resources, to achieve risk reduction in the territory. So if you look at this, these graphs here, you're looking at the risk level and the different structures, which is numbered then from S1 to S24. And these are all regular buildings, but heritage buildings, residential and small, public buildings. Some of them are commercial establishments and so on. So you have S1 to S24, and you can see the total risk is mapped, and also the risk due to each of the individual hazards, earthquake, landslides, fire, and the overall. So this sort of gives you classification, and you see this helps you focus on the low-hanging fruits. And when I say low-hanging fruits, it's where should you immediately focus so that risk reduction there will significantly translate to reduction of losses in a given territory. So this is something that is useful for a prioritization that one can launch. So this, as I said, is a pilot exercise, but there are several efforts across the country by multidisciplinary teams to be able to take forward this sort of a work. The other thing that I wanted to, so this, as I said, it is a decision-making model on allocation of resources for risk mitigation programs. And of course, these have to be applied to wider context. This is only a pilot exercise where we looked at pilot assessment exercise. It has not moved forward in terms of changing anything on the ground. But in my opinion, the first stage is to know what the problem is, have a control on the problem, and then tackle the problem on the field. Having said that, as I said, you cannot have the same sort of approach for a population of buildings and individual buildings. So this is something one would do as far as individual buildings are concerned. So this is in the World Heritage Site of Bagan, but this is again a pilot exercise focusing on one single monument. And this is a monument called the Ananda Ochong. And some of you might have heard me speak on this particular monument in another context. But this was picked up as a pilot exercise for repair and retrofit by UNESCO after the 2016 earthquake. And mind you, it's only in 2019 that this site actually became a World Heritage Site. And this is one of 3,200 monuments sitting in Bagan. This was partly damaged in the earthquake, but after the 1975 earthquake, there was some part retrofit that was executed, not completed, and therefore in the 2016 earthquake, this further got damaged. So this is something that we picked up as a pilot exercise, and this is where you have the time, resources, the luxury to study the building in further detail. As an individual building, you take measurements, you take material from the structure, you study the material, you do some modeling, you do some analysis. So there is a detailed investigative phase. In the other one, it's about 45 minutes to 1 hour on the site. Then you come back, compile all your data, you're looking at a population of buildings. But here, you're actually focusing at the level of a single building, and you're getting into great detail depending on the resources that are available. So you do structural modeling and analysis, you need field data, you need to do some analysis in a laboratory, do some analysis on a computer, and then develop different schemes for repair and retrofit. So whether you can, what is the existing condition of the structure, what is expected to happen. You have to validate what happened in the structure in the earthquake. You then try to look at different interventions. You have a selection of interventions that are possible. You decide, you discuss this with different teams. So you get into a detailed phase where you work out the repair and rehabilitation for risk reduction at individual building scale. Of course, then you have to have a retrofit design, detail that design, and then you also need to go into execution phase. And this particular building work is currently underway, weather protection system, because the work can go over a couple of years and will be executed in time, hopefully prepared for the next event itself. So I conclude here, and in closing, I would just want to state that seismic improvement interventions, and again, I'm focusing only on earthquakes, but this, in most of the contexts that I work in, this becomes the focal point. So improvement interventions would be required when you're looking at reconstructing partly damaged structures, partially collapsed structures, or if you're not looking at partly reconstructing, you're even looking at just repairing and retrofitting, you would have to look at improving the behavior of the structure so that it tackles the earthquake forces or the demand coming from the different hazards in a better manner. So there are different things that one has to study at a given site. Why some things that did not work well in the past? Why did you lose certain structures? Can you reduce those effects? Can you make it? Can you improve that behavior? These are things which one has to really look at it. And I always like to point out this very interesting lesson that came out of the Kathmandu earthquake in 2015, which is the performance of the strengthened Chasilin Mandap in Bhaktapur Darbar Square. There are Darbar squares in Nepal and Kathmandu Valley. You have the Bhaktapur Darbar Square, and in 1934, after the Bihar Nepal earthquake, an important structure called the Chasilin Mandap collapsed. Now, there was a concerted effort to reconstruct it, but reconstruct it by incorporating necessary, because it was clearly understood that the structure was inadequate to face future earthquakes. And therefore, new detailing or improvements over the vernacular historical designs was essential to ensure that it stands the test of time in a next event. And so this is an interesting case study, which is, the Bhaktapur Darbar Square in 1934. You see the missing, the oval here is basically the collapse of the Chasilin Mandap. But then it was completed, it was constructed in 1991 with German funding, and you can actually see that basically the foundation had to be in reinforced concrete, and you see that these steel braces were introduced to connect different parts of the structure. And what's interesting is in 2015, this is the photograph that was taken from inside the structure when there were collapses around the structure in the Bhaktapur Darbar Square. So Chasilin Mandap survived the 2015 Nepal Kathmandu earthquake, though it had completely collapsed in 1934. So this is an important message that you need to intervene, you need to protect some of these structures to ensure that they survive over time. So that brings me back to the cycle that I started with. We can't forget about the impending disaster when we are in the capacity building the mitigation to preparation to the next event phase. And remember always that this is cyclic. It may not come in your lifetime, but you may be held accountable that you didn't do anything when you could and if you could. Okay, I'll stop here and take questions if there are any.
Thank you so much, sir, for a thorough presentation which incorporated all details from what is the cycle of assessment, the seismic zones of India, the disaster mitigation management, disaster risk reduction, and all the hazards and how to prioritize the hazards. Right now, I have one question to start with is when you showed the cycle of how from preparedness to when we have earthquake or any disaster, then we have recovery. So from different case studies or different scenarios which you have seen, where is the weakest part for us? Like where we lag in all the entire system? The weakest thing for India maybe.
No, I think with the series of natural disasters that we've had in the end of the last century and the beginning of this millennium, I would say really the Bhuj earthquake has been an important transition point, and there's been tremendous improvement. I would say it's the Orissa cyclone, the massive cyclone in Orissa and the Bhuj earthquake, which have been really turning points as far as the disaster preparedness in India is concerned. And there's massive work happening across the country. And mind you, we're only 20 years after the Bhuj earthquake. The life of a country that's really still small for a country as large as India. So the place where we still need to pull up our socks is seriousness as far as implementing these at the ground level. We tend to have serious problems in implementation. And this is not only physical implementation of retrofit measures or improved new building design practices. It is also in terms of skill development. How seriously are we taking the skill development forward? These are the areas where some gaps have to be addressed, because otherwise we might have spent enormous amount of money and resources and time, but the effectiveness starts reducing. And so this is clearly an area where Indians are not very serious, and that is where the problem comes from.
Yes.
But I think I'm only positive because there's been tremendous improvement in this situation.
Yes, totally agree. There is a lot of awareness also right now when it comes to risk assessment or disaster mitigation in India, especially.
Yes.
So now we have a question from Mr. Tiago, and he says he's it was a very exciting talk. Arun, thanks. Could you shine some light on how those individual risk indicators, RI, have been quantified in the multi-hazard scenario you shown?
Yeah. So, basically the way this has gone about is a point system. So you're looking at critical parameters that indicate the vulnerability of a certain system to a type of hazard. So you have vulnerability of a certain structural system, materials in structural system to fire, to earthquakes, and to landslides. Of course, landslides is either you lose the building or you don't lose the building. It's a binary sort of a problem, not for earthquakes and fire. So it was more in terms of point systems for different parameters, and I would think it is an expert opinion based a method where you're fixing the weightages across different indicators and then arriving at. So that's why I said this is sort of a pilot and is something that needs to be verified against other methods that are there and field data. So this is really the approach that was adopted by my student Ajinkya a couple of years ago. Yeah.
Thank you, sir. We have Athirai. She's asking, sea level rise is one of the results of climate change. It is not a disaster, but could you share your views on sea level rise in the coastal areas and its impact on the heritage structures like Danish fort in Tranquebar, Show Temple, etc.?
No, I don't know. In the sense, it's not something that I have carefully looked at. So this is, I am in the quadrant where I don't know. So the point is, of course, the vulnerability of certain locations because of their mere positioning, location, would enhance the exposure to certain hazards. And of course, coastal regions are going to be like that. Now, so, in that context, I would like to say one particular point, which is when the tsunami happened in 2004, the Indian Ocean tsunami happened in 2004. Most of us, I was doing an earthquake engineering program, so I knew the word tsunami. But I'm very sure that had I not been doing a postgraduate program in earthquakes, I would not have known what this tsunami was. Okay, so the point is the Tamil Nadu coast or the Coromandel coast was actually affected by a tsunami several hundreds of years ago. And there's clear evidence of a tsunami in these regions. But the human memory, so many generations had passed that it is out of the human memory completely. But that does not mean that the risk that the risk exists. There is a finite risk for such events, and therefore, when Atira says sea level rise, you might not see sea level rise every day. You might not see inundation every day, but there is a finite risk that is there, and hence it's important to do a regional, a local study to first identify the risks. And once you identify the risks, I think the vulnerability needs to be checked, and then things start flowing from there. So the shore temples, for example, we know that the shore temples have been affected in not only due to the effect of the tsunami or cyclones, but also due to wind erosion. So one has to look at what's affecting these structures. There is wind erosion, there's salt action, there are tsunamis possible, then there is cyclones possible. So it is about looking at all of these together. And you're right, but I don't have a very pointed answer to your question. Sorry.
No, next question we have from Poonam ma'am, and she's asking, what is the way forward of the pilot on Shimla?
The way forward on pilot in Shimla is to do this officially. We did this with the help of Poonam, in the sense architect Poonam Verma was working in under the the ADB project in Shimla, and therefore we had access to whom we should contact and get permissions to do this. So it was done purely as an academic exercise for us to sort of get a grip on this multi-hazard scenario. I think what needs to be done is we need to work. I mean, actually, it is the town and country planning department that we had gone to for maps in terms of where buildings are and the surveys and so on. So this sort of an exercise needs to be carried out in a the owner oriented, in the sense the owner is the municipality or the state. It should be driven by them, but these studies need to happen. But I'm sure a certain because the district disaster management authorities exist, some of these would be happening. And probably they are ahead of us. But these are the ways in which such programs can be carried out, and then the risk mitigation measures on the field can be carried out. Disbursement of resources to the private owners to repair their buildings, make it safer, and so on. So that phase is definitely something interesting to look at, but we've not got to that phase. We've not really focused on that. Yeah.
Okay. She further asked that which department is actually carrying out vulnerability studies. Is town and country planning part of it?
Town and country planning will be part of it in terms of the data, but it will typically be driven by the disaster management authorities. So the state disaster management authorities and the district district disaster management authorities, typically.
Okay. And we have Vishwesh asking, is there any guideline criteria for prioritization of multi-hazard scenario? Are they vary and depend on individual situations?
They'll definitely vary from, individual situations. And it is about See, ultimately, you're trying to get a ranking. And of course, if you, it is about looking at the highly vulnerable set. But how many can you focus on in a given period of time is dependent on the availability of resources and the availability of time. So these follow fundamental principles. Internationally, they are the same, but location to location, these can be different in how they are worked out.
Okay, we will take the last question. It's from Bhanumati, and she asks, how can the public be prepared for the disaster in the pre-event phase?
See, this happens quite a bit because the disaster management authorities at the district level or the city level carry out drills. They carry out drills. These are drills that are mandated by the National Disaster Management Act that often fire drills, earthquake drills, depending on the prevailing hazards in a given place, they have to be carried out. And pamphlets are distributed, or you must have seen there are ads that are made by the disaster management authorities that you can see on television, on radio. They update you on what you should be prepared for. And there are pamphlets, booklets that are made and given to house owners, to hospitals, to different facilities. So there is an entire exercise that needs to follow up of engaging with the main stakeholder whose risk you're trying to reduce. So there are several public activities that go on and have to go on, and this is the prerogative of the disaster management authorities.
Okay. Thank you so much, sir, for
Thank
your
you.
presentation.
Thank
you.
Yeah.
So now we have Mr. Rohit Jigyasu with us for next presentation. And Rohit Jigyasu has a postgraduate degree in architectural conservation from the School of Planning and Architecture in New Delhi. He obtained his doctoral degree from the Norwegian University of Science and Technology, Trondheim, Norway. His multidisciplinary research focused on the role of traditional knowledge in disaster mitigation, especially in the Southern Asian context. A past ICROM consultant, he has also worked as consultant with organizations such as the Archaeological Survey of India, the Indian National Institute, UNESCO, and the Getty Conservation Institute, where he delivered training on disaster risk management of cultural heritage. He has contributed to several international publications. Rohit sir is currently working as project manager at ICROM and works closely with ICROM project associates and consultants in Shahjahan and in Rome. He is a conservation architect and risk management professional who has served as UNESCO chair at the Institute of Disaster Mitigation of Urban Cultural Heritage at Japan and senior advisor at the Indian Institute for Human Settlement. Welcome, Rohit sir. Over to you.
Thank you very much. Thank you for giving me an opportunity. So I think we have been hearing some very, very interesting presentations, and I think there are a lot of things that we will revisit because they have been already covered by our resource persons. But what I'm gonna try to do in this presentation is I'm going to try and connect it to heritage conservation as a field, and how does risk approach impact the way we manage our heritage. So let me switch to my presentation, just a second. All right, I suppose you can see the...
Yes, sir.
Yeah, perfect. Okay. Okay, so the title is Risk Assessment as a Tool for Prioritizing Conservation Interventions for Built Heritage. Before I go into the topic of my lecture, let me just give a brief on ICROM. It is the International Center for the Study of Preservation and Restoration of Cultural Property, headquartered in Rome, but with the regional office in Sharjah for the Arab region. It is an intergovernmental organization working in the service of 137 member states to promote conservation of all forms of heritage around the world. Interestingly, it was established in India in 1956. I mean, the decision was taken in India in the 9th session of UNESCO. And ICROM has been working on various dimensions of heritage preservation with multidisciplinary group of professionals, which include scientists, conservators, museum curators, site managers, archivists, researchers and archaeologists. And there are five main areas in which we work: training, information, research, cooperation, and advocacy. And here you see our Director General, Dr. Weber Ndoro, who is currently heading the institution. Okay, let me move to my presentation, and I'm going to start with how the understanding of heritage itself, has undergone a shift over time, because that's going to be bringing me into this whole concept of risk eventually. Not long time back, the heritage had a very monument-centered vision, where we were looking at buildings or structures, and the only way we could really deal with um, these sites, whether monuments or archaeological areas, was that we will have a site protected by creating a fence around it, and maybe restricting the entry, and basically turning it into a pristine area that you cannot touch or change, and you won't be so much bothered about what the context is around it. So that was the kind of approach which was more dealing with built heritage in like a museum piece that has to be preserved for posterity. Well, that meant that our predominant considerations were really about dealing with what is most significant. Visual aesthetics or symbolism was the main criteria. uh, we will generally go for protection by exclusion through boundaries and buffer areas, and look at conservation mainly in terms of preservation of physical fabric. And very importantly, and this is something that I'm going to go back to later, is that we treated past as separated from present. We looked at time in a very linear manner. And for us, it is about protecting what comes from the past. That is defining what our role is as a heritage professional, and which also meant that development was seen as anti-conservation, and the similar way the other way. If you do conservation, you are anti-development. So that was the kind of predominant belief in what you look how you look at heritage, and what you look at in terms of your role as a heritage professional, which also essentially meant that conservation interventions were aimed at, as I said before, preservation of built fabric. And we would think about undertaking various interventions such as repairs, restoration, retrofitting, reconstruction. All these would be our conservation interventions as we would understand them. And if you look at many of ECOMOS charters, that starting from Venice Charter onwards, they were really emphasizing on this approach of really trying to keep what is there as it is, and do all that you can do to keep the status quo. Well, if I go to the new understanding of heritage as it has evolved over the years, it's gone to a different level, where we are not looking at it as something static, as something that you have to preserve as it is. Rather, you would see the built heritage is seen more in a dynamic manner, that it is not standing in isolation. It has a very close contact with people and the environment. And in that sense, you look at both nature and culture in terms of how they interact with each other. And most importantly, you are considering both continuity and change as essential characteristics of heritage. And you would rather think that maybe this has always been like that, but I can tell you for sure that even in 2008, when I was in my first ECOMOS General Assembly, I was very surprised to really note that most people were very allergic to the word change, because for them the essential objective of heritage professional is to really neglect change, to reject change, and keep things in a more static manner. So when we kind of look at heritage in a more dynamic manner, One of the things that also comes out very importantly in this is that we cannot look at buildings or landscape or different elements in isolation, but we look at them as a system, as systems that are interconnected with each other. So if you have a temple or a building or a group of neighborhood or a neighborhood, it is not supposed to be looked at as individual pieces of buildings that you just club together. Rather, you look at the entire system into as to how it is linked to each other, uh, which essentially also meant where it is located, how is the relationship to the landscape around it, what is the visual linkages of a place to its setting. And all these become essential characteristics, which essentially implied that you look at you in a way do a systems mapping. You look at different connections between different elements that define a heritage, and in that sense it is not a heritage building or a heritage site. It becomes a place, and you call it as a heritage place with different components, different elements that are interconnected in multiple manners. So that essentially brings us to this point that when you are recognizing that heritage is going to be always changing and evolving, the only constant that you recognize is this change, because it is an essential element of our existence, and we just cannot neglect it. We just cannot avoid it. We cannot overlook it. So values, now coming back to values, again, if we have to look at heritage in that dynamic manner, it also essentially means that values will change over time. They will not stay the same, and we cannot just think of anything to be having the same value as it used to have at a certain point of time. So about this movie was, and the one of the important elements of this movie which kind of led to the popularity was the Rajdoot motorcycle, right? And that became really the craze of 70s. I still remember when I was a kid. I mean, this was really the one that you would like to aspire for. And then as you moved over time, this motorcycle had was it was considered like out of fashion. And you will go for Hero Honda, you will go for new bikes that are in the town, and you would see this as something which is kind of not something which is to be aspired for. And then you come to a new state when in 90s, or even now, you turn the same motorbike which you had rejected some while ago, and which was really something which was in fashion some years back, as a piece of museum, because you have given it a new value. The values have gone a complete shift over time. So that's something that I would like to bring forward, and that also not only means that the values, as you define values in a more identity or in an associational manner, but even the market value gets changed. The same object which you had which had become redundant and probably was sold in the scrap market, is now maybe worth some value as a museum piece. So you see, that is something that is very important for us to keep in mind, that values have to always undergo a shift over time, and they may go down and they may go up again. And that brings me to this important issue of looking at the changing context. And changing context could be cultural, where values change over time, as I just explained to you; social, where communities change over time; economic, yes, if you think about economic growth, how does that make a change? Environmental change, and I'm going to come to it in the context of climate change. Changes in institution or the policies as they are there, and also very significantly attitudinal change, how people's needs and perceptions undergo a change. So we have to understand that all these dimensions which define heritage in a certain context are going to go through a change. and we need to recognize it, and we need to understand what kind of change is happening or has happened. So now, in a way, trying to see this in terms of how we look at this change and encounter change in an unexpected manner. There's a very famous book, Black Swan, and if you get a chance, you must read through it, because it really tells you that there could be unexpected black swan events that are unlikely to happen but would have serious consequences if they had happened. And we are facing one of this black swan event. Now we are going through it right now. Who would have imagined last year around the same time that something like this will be happening? So there is this kind of a level of uncertainty, or kind of events that you would never expect. But so we are chartering an uncertain future. I'm going to go to future in a while, but let's look at what is a risk, and how do we define a risk when we look at it from the perspective of the situation in the future. Very importantly, it is about the chance of something happening that will have negative impact upon its objectives. But let's not look at it in only in terms of the negative impacts. There could be some positive impacts as well. Uh, it is about future, but it is based on the present, and I'm going to also question that later on as I move ahead. But you definitely are not just making wild guesses. It's definitely based on something that you observe and you evaluate, you analyze, and you base your future. And risk is, of course, always in reference to a particular aspect. So when Arun was talking, he was mentioning risk from the perspective of earthquake. You can look at risk with regards to flooding. You can risk with regards to even risk of me going out and getting wet in a rain. So it could be risk in different levels, and risk has to be defined with reference to a certain aspect. And also we live with millions of risks. In fact, there is no life without risks. And so what is important for us is risk makes sense only when we look at it as a relative thing. We compare, this risk is low compared to that risk, and in that way we go for prioritization. So you can only evaluate when you compare. You can't just say I'm at risk or you are at risk, and in that sense you will basically come up with 100. Everybody will say we are at risk, and then what sense does it make? So risk and understanding of risk will only make sense when you compare it to something and say that, look, this is at higher risk than the other. And so that kind of a relativity is really an essential part. And lastly, in this understanding of risk, time perspectives become very important. What you have as a short-term risk might be very different in the long-term risk. And that's very important when we look at it from the perspective of heritage, because maybe there is a risk which is short-term for human life. But when we think about heritage, maybe the risk is very long term. It might be that the whole painting is going to get lost, but that may take 20 years, 50 years, or even 100 years. So both of them, whether short term or long term, are important, but they could be very different from each other. And so we have to really bring in the time dimension as well when we look at risk. So Arun had very nicely brought about disaster risk management cycle. And I want to just mention that risk is something that will exist at every step of disaster risk management cycle. So it's not like we only think about risk only in a pre-disaster situation. We may think, we have to think about risk only when there is no disaster, and we are thinking about what kind of risk can be there when a disaster takes place. But actually, risk can be at every step. Even when a disaster is taking place, when an earthquake has happened, there could be another kind of risk which would be for that disaster situation, which will be very different. For example, when we had earthquake in Nepal, there was risk of course, aftershocks, but also there was a risk of rain coming in and damaging the cracked buildings. So you have to think about risk as something that has to be evaluated at every step, whether it is a before a disaster situation, during, and it has to be looked at, as I mentioned before, both in the short term and in the long term. So that's where I just kind of try to say that you need to think about, okay, if I'm in this situation, what could happen? Maybe maybe in the next few days from that time. But that time where I'm living right now could be a situation very different than a situation if I may evaluate, let's say a year or even a month later. So, an essential thing that we have to always be thinking about, and I think our previous speakers have been really talking about it, is dealing with this two things, change and the chance of that change. And we need to really look at both, like what is the change happening and what is the chance or the possibility of that change really taking place. Um, so assessing disaster risks, as I think has been already covered, and we need to really keep in mind, is this combination of looking at the probability or the likelihood of something happening and what is going to be the severity of its impact or the consequence of it. And I think it's a combination of these two which has to be always keep kept into consideration when we kind of try and look at risk to any heritage site or property. And another thing is that when we look at impacts, yes, we look at the probability, but when we look at the impact, we also have to look at the impacts which are short, which are direct, which could be like the damage to the building, or the certain structure can collapse. There was an earthquake in Turkey, and a lot of structures have crumbled down. So that's of course a direct impact, but you have to also think about the indirect impact. How does it impact tourism? How does it impact economy of a place? How does it impact the way people live? I mean, these are not the direct impacts, but they are also indirect consequences. We have to consider both the direct and the indirect effects. So I just want to now come to another interesting thing. So if you look at this image, you are asked, I need to know what the risk is. How I know what the risk is? So uh, it's something to think about now. Very cleverly, and what will you observe? You will do a very smart thing. You will just lift a collar, and you will see how much of that color has faded in the past, right? So you make your understanding of risk on the basis of the deductions that you make from the evidence of damage to the heritage. What damage you see will tell you what the risk is, right? So it has gone through this kind of fading in the past, and so it tells me what can happen in the future. It gives me a kind of indication, which means that I'm deducing from what I see to arrive at what might happen in the future. But what I want to emphasize is that deductions are not enough. And I want to go back to what I was mentioning before, that you cannot deduce from what you see in the past, because when you see what's happening in the future, it's not always coming from what you see in the past. And I will explain it to you a little bit more. If you look at how we evaluate growth, we look at time versus progress. So you can have a linear growth, which results from repeatedly adding a constant exponential growth. It's kind of multiplication of a constant. So you can come up with this linear curve, but actually it is not happening in the same way, right? I mean, the things are actually changing in an exponential manner, and there is always a surprise factor in the way things happen. So I just go back to the example I was giving earlier, that was COVID-19 situation. There is a surprise element. It is kind of exponentially changing the situation. So what I'm trying to explain here is that when you think about deducing from the past, it may not give you what you will like to know about the future. Sometimes you have to go from that linear understanding to an exponential understanding, and that requires you to look at a lot of modeling. And I suppose you had some presentations which explain what the modeling is, and that modeling will tell you how exponential growth can be how exponential risks can be calculated and understood. So that's an important thing for us to keep in mind, that we cannot always deduce. We have to go from this deduction mode to a predictive mode, adding in a lot of variables that can exponentially change the situation as it would be if you would just leave the situation as it is. And a very very easy way for us to understand this exponential change is what's happening with climate change. So climate change was always there. It's not that suddenly we discovered climate change today and things started to change. It was always there. But what has changed is the exponential change, the exponential changes in environmental conditions. There was a change, but now the curve has started to become extremely, the curved in the sense like it is really not based on how changes were happening in the past. And that also essentially tells us, I mean, if you look at this graph, which shows you how the greenhouse gas emissions would be, you can look at this red line and you can understand that in 2100, if we don't do anything now, and let's say we stop, we let things continue like as they are now, we will hit that kind of red curve. Even if you stop doing anything now, I mean, we'll say, okay, we will let things be like that as they are now, things will still change, as you will see in this blue curve. So, what I'm trying to get at is that you have to really look at future in a very in a very exponential manner, and you need to control a lot of variables to predict how things would be in different situations. If variables are as they are now, if variables are going through a little bit of tweaking here and there, how the future is going to change. So everything has to be modeled and taken into account, and it cannot always be counting on what has happened in the previous cases in the past. So we're coming back to climate change. Rising temperatures and changing rainfall patterns due to can lead to increase in temperature and decrease in mean precipitation, which can cause the severity of droughts and heat waves. So again, you see that there are multiple things that can happen as a result of climate change. There could be warming ocean temperature, and that can generate more stronger hurricanes, and it will also lead to flooding in the aftermath. There could be coastal inundation. There was a question also raised before due to sea level rise. There could be also severe droughts that can lead to increase in forest fires. There could be also El Nino effect, which is another kind. So, what I'm trying to explain is that there could be multiple things kind of happening, one in relation to the other. And I think Arun mentioned before multi-hazard perspective. And I think this is also a multi-hazard perspective I'm bringing forward and trying to explain that when we start to look at how things will lead from one to the other, just like follow up of one to the other, multiple things may unfold, and they may lead to a certain kind of a situation in the future. I also wanted to mention one thing, that we always think about climate change as something where everywhere sea level is rising, everywhere temperatures are rising, everywhere humidity. It's not like that. Actually, there is nothing called change in climate. Climate is getting more variable. The variability in climate is increasing, which means that there are also areas where sea level rises. Actually, there is not rise, but there is a drop in the sea level. It is very uneven in the earth. In some places there is very heavy rainfall, but in some places we face droughts as well. So we have to be able to not just make a very universal kind of conclusion, and that's where predicting what is going to happen in the future becomes so much important. It is not a universal recipe that we may come up with. And so I'm not going to go into detail, but there has been a lot of predictive modeling being done for climate change and gives us a lot of interesting scenarios that can unfold if we let things go as they are right now. And mind you, this is when we let things go as they are right now. If we continue to grow, or if you continue to progress more on what we are doing now, I mean, we will make even more stronger impact on many factors. And then of course it is going to have, as I have been mentioning from before, it will have a lot of indirect impacts. And it's so critical for us, because when we are focused on built heritage, I think we forget that built heritage in itself is not going to be the only thing affected. There's going to be effect on the livelihood, there's going to be effect on the level of water, food production is going to be affected. There would be more conflicts because of that. And that is eventually going to affect heritage as well. So we have to take into consideration both the direct impacts, which are more easy for us to understand. A lot of us who are architects or engineers would be able to really look at it, but often we forget about these indirect impacts that we also have to take into consideration. And when we think about what may happen in the future, another thing that we have to also keep in mind is the level of urbanization that's happening. And there's also a lot of interesting modeling done on how we project our cities to grow in the future. So on one hand, you have climate changing. On the other hand, you also have an exponential increase in urbanization. So these two things have to be also seen as influencing each other. Climate change affects many times people migrating to cities, and at the same time climate change has very unique effect on cities, and when cities develop there is an effect on the climate change also. So there is a effect on both sides, and this kind of a connection has to be recognized when we look at risks. So I come back to these points that have been raised by Arun, and also in the previous speakers, that we need to look at effects of climate change especially with regards to disaster risks in relation to the nature of hazards, like how a frequency may change, and then in relation to exposure, where certain locations are getting more exposed. I'm again emphasize that this is also going to be very much variable. No, there will be a lot of variability, and in relation to vulnerability, where there are certain factors that may actually add to the vulnerability, for example urbanization or environmental degradation. And let me come to this whole crisis that we are facing right now, which is that of COVID. And that's also connected to urbanization and climate change. I mean, this has affected the way animals' habitat has been altered, how people, how the animals live, where they live, and who eats whom. And in fact, that's also having a very direct impact on what we are facing this time. So, it's a problem that we try to compartmentalize things into different, if we deal with virus, we will look at virus as a only virus situation. If you look at cities, we look at urbanization separately. And if you look at what's happening to our built heritage, probably will not consider the other factors. So essentially, when we have to consider risks, it's so much important that we start to see these connections, and we start to make a prediction on how these impacts are going to unfold in the short and in the long term. And that's what I wanted to emphasize. The disasters are collaborating more than ever before. We look at pandemic, or we look at disaster, or a climate, or a conflict, or even the effect on economy. They are all interconnected, and it's about time that we recognize that. Now I'm going to come to this other important element that we have to be always considering when we think about risks, and that's to look at uh, fast variables or catastrophic, hazards, like maybe lightning or earthquake, but at the same time not forgetting about the slow factors, because a lot of these slow factors, slow variables, whether it is weathering, whether it is vegetation growth, whether it is changes in the humidity, this is not happening instantly. This is slowly and cumulative happening. We are all facing the problem of pollution. I mean, this is again something which is cumulative, making a change. But it is really, really important for us. And again, the certain cropping patterns are changing. If we looking at cultural landscapes, we have to also understand that certain crops cannot grow because the environmental conditions have changed. There is less water, or so that also is going to affect. In case we are looking at vernacular structures, maybe we are not able to build houses in the same raw material or thatch as we used to do before, because it is no longer easily available. Again, these are all the factors which are connected to this process of change that is being influenced, and that is affecting even our built heritage as we understand today, right? So we have to see these connections all the time, and at the same time we have to see where we are heading in the future to have a very good understanding. So again, as I said, humidity, temperature conditions may be influencing, and weathering, for example, was always there, but what is the rate of weathering, how much is the rate of weathering increasing, and that's going to again be influencing what may happen in the future, or the changes in humidity, how they are going to affect the frescoes in the church, it might not be the same way as it is now. So it's really, really important, and that is something that I want to emphasize, that when we look at risks, it's very important that we start to see the connections between what is catastrophic or what is instant, which we are always paying an attention to, and what is slow and progressive, and which will take eventually several years to materialize. But both of them will be connected to each other, and that connection has to be always recognized if we assess risks. It's also important for us to understand that risk always travels a certain path, and that path has to be understood. That path can go from a larger territory or a site, and it can go down to buildings, and it can go even to the smaller extent to how it influences materials. So understanding the risk paths from the macro to the micro level is as critical for us to understand how things are going to be influencing each other over time. And then we need to go and see what's going to be uh, the kind of impact on heritage. And if we have to look at impact on heritage, it's really important for us to go back to that whole understanding of value that I was talking to you before, and see how can we calculate loss of value in a disaster. It might be that certain values might be able to be easily recovered, but certain values might be very difficult to get recovered. So how, for example, this, maybe you can recover a part of it, but if it is totally burnt out, maybe you cannot recover anything. Or even when you look at new kind of heritage, let's look at audiovisual heritage. We used to use these cassettes before. Maybe if something happens, we will completely lose the value. If you may recover this as a material, but the value lies in the recording in it, right? And if you're not able to recover back that recording, the loss of value is nearly total. So again, it's really important for us to see how all this actually is going to influence values that are embedded in our built heritage over time. And then of course how these will get transformed even during other factors like social and political disruptions. So that's what I always emphasize, and I would emphasize here, because most of you are students who are looking at who are listening to these lectures, that even if you look at these multiple things, it's very important for us to recognize these multiple connections between them. The lateral connections, it's not a linear game. It's a game where multiple things influence each other, and that kind of a complex thing. That's why I say, even when you look at heritage, it is a system, and when you understand risks, they have to be understood also as a complex system. And that leads us to really go to the next level, where we need to create scenarios, because that's where we would like to actually imagine what can happen to our heritage site based on all these evidences that we have gathered over time. And that scenario making is a very important step on risk assessment. And this is an informed scenarios. As I was mentioning, it is not like any movie writer sitting and writing a story for a movie. You are actually collecting a lot of evidence, you are doing a lot of predictive modeling, and then on that basis you create these scenarios, which will connect series of events that can unfold, the time frame in which they will unfold, and how there's going to be an impact on heritage and the values in the short and the long term. And that's the way we do construct scenarios. And you don't create one scenario, you create multiple scenarios, from the best case to the worst case, and you deal with how addressing them. So scenario creation, scenario, I'm just showing an example. There's no time for me to show, to give you the details, but you can come up with these very detailed scenarios. And some of the scenario making that we have done, unfortunately it has even come true in reality. So the way you make really realistic scenarios will also influence decision makers. to understand what may happen in your to your built heritage in the future, and then try and give you a support, to do things in advance, which is what is the real reason why we do risk assessment. And that's something that I would like to definitely emphasize. So I will very quickly talk about one aspect which is important for us to keep in mind, that we always look for data and information, but we will never get precise data and information. So we should not be discouraged by or spending too much time in collecting a lot of data and information. There is always a certain level of uncertainty in the data that we will be able to collect. But it's okay. I mean, we should collect whatever we have and work with it. But don't be bogged down with collecting too much of this data, which will, of course, increase the certainty of what you say. But then, does it matter if you are saying it with 20% certainty, or if you say it with 30% certainty, or 40%? Maybe not, because the larger trend will still be the same. So we have to be always thinking about uncertainty of data, and then be able to really coming back to putting together probability and impacts, and assessing risks in low, medium, and high. And then, of course, visualizing risks using different parameters. This is something we did for one of the traditional neighborhoods in Kathmandu, where we put in different parameters, and we put in different scenarios, and then try to create the situation as it would unfold. So we can use even creative tools like GIS to visualize, because visualizing risk is not only important for you as a researcher or as a professional, but it is also very important for the decision maker. Because if he's not convinced, or he or she is not convinced, then why will he or she invest, or give you the budget to do something that has not happened yet and is more likely to happen. So I'm coming to the end of my presentation, but before I conclude, I want to mention that there is always a certain level of risk which is going to remain. You can never say I'm going to make my built heritage with no risk at all. It's not going to be possible. So the important consideration for us is how much risk are you willing to accept? And that's something you have to be always deciding. There's always a threshold that you have to keep in mind. Because if I say I want to make my building safe from 9 Richter scale earthquake, right? I will put a lot of money in one structure. But is that fine? Or if I can do my interventions for more structures, but I reduce the level of, I say I will accept more risk. So even if there are little bit cracks, I can easily repair them. But I think I'm going to save a lot more buildings by, and with little less resources, than putting in too much of money in one structure and trying to reduce that risk to, when my bar for that risk is much higher than it would be for. So, we have to always think about optimization of how much risk reduction measures we are going to accept, because otherwise we will may put too much. And I want to actually go back to the same issue, the same example which Arun had shown in Bhaktapur in Nepal. And this is a discussion we'll have to do. I mean, how much money are we going to put in it? How much risk are we going to reduce compared to if I am able to do maybe a lesser kind of a strong intervention, but a lesser amount of money, but maybe able to accept a little bit more risk, but are able to do more interventions than in just one structure. So that kind of discussion is very important for us, especially when we are thinking about prioritization. So I'm coming to the last two slides, and and this is my way of passing on my presentation to Poonam, who is going to talk about resilience, because I feel that we need to switch. I mean, how do we transit from risk to resilience is an important step for us in the way we deal with heritage conservation. And conservation in that sense, when we look at it from the risk perspective, is not about preserving, as I started my talk with, but it is about management of change. And how do you manage that change? How do you consider heritage values that are also undergoing a shift over time, and how do you deal with them, and how do you take into account what may happen in the future, which is going to be taking into account all the uncertainties that I explained to you, is going to determine how we are going to address our built heritage. So we need to put all these different pieces together, and just looking at heritage conservation and management in isolation is not going to do justice to us. So heritage management with the risk of lens in times of uncertainty means that we focus on mitigation, preparedness, and adaptation. And I emphasize the word adaptation because that's pretty important now. We look at a multi-hazard approach, as has been already emphasized a lot by the previous speakers. And risk has to be seen as a way for us to monitor things. It is not something that you do once. There's no point in doing risk assessment in one go and then forgetting about it. Risk assessment only makes sense if you do it periodically, if you do it after a certain period of time, so that you are able to assess whether my risks are increasing or decreasing. And in that sense, it is a way for us to monitor our sites. It is a way for us to prioritize our interventions, and then of course reduce vulnerabilities for the future. And that, I mean, these are the things that we always have to keep into mind. And that means that heritage conservation and management is not just a preservation thing for us. It is as much of an innovation, as much of an experimentation, as much of a thing which deals with something that we don't know but we want to deal with it, as it would be otherwise. So just to, before I say, close my presentation, many of you are students here, and ECROM has many programs which we run, and we do invite internship applications. And so if you are interested, you have to apply, and of course the internships happen next year, but do go through ECROM's website and do submit your applications in case you are interested to gather experience. And I also invite you to attend, we do regular lecture series. I don't know, maybe some of you have listened to our webinars in the past, but there's a webinar that is going to happen on 5th November on integrated management of historic cities, challenges and opportunities. And I invite you to attend it. You can register it on our website, and we will have interesting range of speakers. And the whole idea is, again, to look at not preserving cities, but how do we manage cities by integrating heritage concerns in urban development and planning. So thank you very much. And that's where I close my presentation.
Thank you so much, sir, for walking us through the risk that present day scenario pose on cultural heritage, and a very interesting take about how values change over time. Um I have one question for you. It's in one of your presentations. Even here, you mentioned how certain risks which are in a lower priority range, they sometimes pose a greater threat eventually. And in one of your previous presentations, which I attended, you had talked about how the secondary risk in the southern eastern countries, Asian country, had posed a greater threat after earthquake and tsunami. No, the nuclear hazard which was supposed to happen. So can you throw more light on these secondary risks turning hazardous? So
Yes. So, you know, the point I want to make is that we have often been too much hazard centric. So if we say we want to do risk management, we will say, okay, how do we make a risk management against flooding, against earthquake, against fire? But the important consideration for us is that, first of all, not only we have to look at all these different things as how they connect with each other, whether they are natural or human induced, because it's not only about natural element hazards but also human induced hazards. But at the same time, you have to also think about different. Built heritage is one part, but it is connected to economy, it is connected to society, it is connected to environment. So there would be direct and indirect impacts on them as well. And so our interventions have to take into consideration those elements. Otherwise, our partial intervention here and there is going to be maybe good for now, but maybe it's not going to be long term effective, and it's not going to be sustainable as well. So that's something that I want to emphasize pretty much.
okay, thank you, sir. We have a question from Noor. What are the current theoretical versus operational gaps in practice? especially when we are looking at how cultural heritage loss impacts existing population?
Okay, that's a very interesting question, but it can be read in many different ways because it's pretty philosophical in the way it's posed. But I would just say that the problem in today's world is that, and I would say conservation world has somehow evolved in a little bit of a cocoon. It has not been part of the larger discourse. And in that sense, whatever we have been saying, even the categories that we have been making on a theoretical basis have not turned into operational level, right? So many things have not even have failed in many ways. So if we have to, that's where the gap lies. And if we have to turn that theory into practice, an important thing for us is really as heritage professionals to work with all the other different sectors with whom probably we have been for long withholding ourselves, and what we have to do is, and that's what I have done in my last 15 years of my career, is that I have gone out of the heritage world and have connected to other disciplines. And in that process, you actually find not only yourself more relevant, but you learn a lot from what others are doing. So that's where I would say a theory has to be connected to practice, and a lot of lessons are out there for us to learn from.
Okay. So one of the questions which I have in mind is about the slow variables. So when you talked about slow variables, I feel creep is an important slow variable. So how to deal with that, keeping in mind that this can pose a greater threat in future?
Which one is the slow variable you said, Nigar?
Creep, the effect of weathering and generally the
Yeah,
lifespan of the building.
yeah. So that is actually weathering or deterioration or decay is a part of anything which is existing. So I think it's something that is always there. But what we often forget to understand is the rate of change. And I think what's important for us is to start working on the rate of change and start to arrest that rate of change, because change will be there. So, the moment we say we are going to provide some kind of treatment which is going to stop that thing from happening, I think we are going against the nature. So the essential thing for us is to understand where the rate is increasing, and then we try and slower that rate of change. But at the same time, accepting that rate is going to change. The second thing is that how that little change in the rate is going to affect the vulnerability to even the catastrophic events, whether that is earthquake or bigger events, is something we fail to recognize. Because we may say, are we going to do retrofitting against earthquake? But are we addressing those factors which are slow but are actually creating vulnerability in the long
Yeah.
run? So our intervention might be short-sighted in that sense because we have done it for the earthquake. And another thing I want to emphasize, since you have raised this point, is that often when we concentrate on one element, we'll forget about the other element, right? So we may reduce vulnerability to one hazard, but we may increase vulnerability to two more hazards, right? So again,
Yeah.
that's why it's important for us to keep that kind of a larger picture in mind.
Yeah, that's what came in my mind, because if I'm retrofitting for seismic actions, maybe I'm deteriorating the material more, which is already weathering, and it may be
Yes.
the cause of collapse in future.
Yes.
So okay, we have one question from Neha, and she says, "Is it right to counter an argument of saving original values with changing values, as showed in Jay Viru's bike?"
uh, I think every value has to be evaluated in the present context. What do we value today, and what do we do today for how you recognize the value today in a society in journal is what we have to work with. We cannot, of course, imagine what the values will be in the future. So we cannot really go and start creating a conjecture that this is going to become very important. And we cannot go back into history and say that was very important because Shah Jahan used to live. So, I need to bring it back as how Shah Jahan used to live, because maybe there are other sets of values that have been added to it than what it was when Shah Jahan used to live. And I need to recognize all those sets of values that have been added over time, right? So that's why, in my view, Jai Viru's bike has to be valued for what it is today, taking into account all its history and all the layers that it has accumulated to what it has come up to in today's context. But we cannot really, try to either go back in the nostalgic past. Neither can we totally, imagine a certain future which we have no clue about. So that's what my response to you.
Thank you, sir. I think we don't have any more questions. Thank you for a very interesting presentation which incorporated all the aspects of risk assessment. And now we move forward to Poonam ma'am. Thank you, Rohit sir. Thank you. Hello. Yeah. So next speaker is Ms. Poonam Verma. She is graduate in architecture from India. She has done her postgraduate in conservation of historic buildings from UK. She is an architect, building conservation professional, researcher, and a writer. Founder director of Goa-based award-winning studio Archinova and Virans, with 3 decades of Indian and international experience. A Charles Wallace Fellow, she was consultant to Intact Jaipur for conservation of 22 listed sites and designing heritage walks at Jaipur, Amber under ADB funded RUIDP projects. Her Goa-based studio, Archinova Environs, has revitalized numerous Goan heritage homes and couple of privately owned palaces in Rajasthan. Since 2016, she is the cultural heritage management expert for ADB-funded IDIPT projects in Himachal Pradesh. The team completed rehabilitation of Shimla Town Hall in November 2018, while conservation of historic urban precincts and buildings in Mandi town. She has a number of publications under her name, and her latest book is Mapped Heritage of Panji, Goa 2017. She is the coordinator for Risk Preparedness National Scientific Committee of ICOMOS India. Welcome, Poonam ma'am. Look forward to your presentation.
Thank you. What a wonderful afternoon. My goodness, amazing, no? And so I pick it up, and I'm sure everybody is kind of waiting to get on with. So I'm going to look at resilience, and I hope my screen is visible to everyone. Yes, Nigar? Okay.
Yes.
So thanks a lot, CEPT University. Here I am sitting. I always begin with this photograph simply because it is Bhimbedka's site, and it actually puts human beings on this piece of land of India to 1 lakh years. And I can't begin to tell you how exciting it was to think about sitting there, about resilience of human beings and the journey they have made. Team members, I also acknowledge of RUIDP, IDIPT, and Archinova Environs. Projects are always teamwork. Perspectives that today I share are mine. Let us begin. So the word resilience has become rather popular, no, in recent months. In order to decode it, I decided to explore my own experiential learnings. And today I share these with you. And it may feel like an echo, and I'm glad about it, with the many of the authors that we have heard today. I'm going to just take a pause. Nigar, is my voice clear? Because I'm not very sure of my signal.
It is a bit of echoing and vibrating, ma'am, if you can.
So I'm going to do... Okay, so how do I... Let me just... I'll stop the video. Is it better now?
It's still echoing a bit.
So should
Maybe
I...
you can, I think it's better now. You can go on.
So I grew up in Roorkee, born in late 60s. And these are the places that I'm going to be talking about. So we'll be traveling up and down the countryside. And I can sum up my upbringing in 2 phrases: don't waste and be responsible. It was a privilege living in a well laid out housing campus of a CSIR laboratory with parks, broad roads, as well as clean tree-lined avenues, safe and secure and maintained campus with 24/7 electricity and water supply. The first memory that came to me while thinking about resilience was 1977, when I was aged 10 years, at apartment C9 in CBRI colony, month of July. It had rained whole night and we woke up to 6 inches of water surrounding our ground floor apartment, part of 5-flat housing with no electricity. Heavy downpour continued. By 2 p.m., our taps ran dry for the very first time in my memory. Rain paused around 4 p.m. and desperate, most had to venture out in knee-deep water to seek drinking water for the households. My father was outstationed, and thus I, with my 8-year-old brother, took buckets and pails and followed the beeline about 50 meters away to the lone standing forgotten hand pump. 30 families of the neighborhood were thus served and saved for the next 3 days by this low-tech Lone Ranger hand pump amidst more rains. Eventually, water receded, electricity was restored, water tank for the colony was filled up, and gravity-fed water supply resumed. On his return, my father was aghast by our saga, and matter was taken up for inquiry. As we, the 30-odd families in the north end of the colony, had suffered while their life remained normal for the majority who were living in the southern side. We learned that primary issue was the land grading, which was the lowest at our apartment's end, but also because further down the terrain, at the lowest level, before the land rose again, a catchment drain had been purposely made in the master plan to carry the rainwater away to the fields, but was forgotten of its function in short 2 decades of its inception. Instead, the land surrounding it had become dumping ground for debris and garbage. The water channels were disrupted, and thus with reduced carrying capacity of the drain and blocking of water flow by the high mounds of debris, the heavy and continuous rainfall together resulted in severe inundation and waterlogging in the area. 3-day deluge, which appeared to be an extraordinary event, became so because of mismanagement of residential area, also relaying that mitigation factors encoded in a landscape planning can be so easily obliterated when the caretaking changes hands and can cause highly distressing man-made disasters. While the forgotten, discarded, low-tech hand pump is the true instrument of resilience in this experience, what followed was also of significance. Father applied for the change of house, and 3 months later we moved to another flat, B71. Same type, but on a higher ground, on the southern side of the campus. Years later, it dawned on to me that those 30 families that experienced the distress, only 2 blocks were for the officers of the scientists, and the rest were what we call today the LIG housing for non-gazetted employees of CBRI. Thus, the dumping of debris, mismanagement of land, and storm water channels had gone unchecked. Fast forward 2005, 15 years ago, also month of July, place Mumbai, heavy downpour, formed the rhythm while I tapped away on my comp, lost in understanding the traditional architecture of Coorg, and suddenly became aware of power failure, also a novelty in Mumbai, which is amongst the few cities where electricity seldom fails. Peeking out from our second floor apartment window was aghast to see 6 inches of water, noticed as 3 p.m. in our complex compound, had risen to 2 feet at 4 p.m. Promptly, I called my parents living in Roorkee and requested them to tune in into the news channel and relay if anything was being mentioned in regards to Mumbai, and was promptly told that it is being called extraordinary rain event causing floods in Mumbai. Promptly, I called Walter, my husband, and asked him to start walking home from his office. That was 5 kilometers away. And dramatically, just as I finished my call to him, the line went dead. Walter left his bike at office and started on foot, and very soon the knee-deep waters became chest-deep, and he, along with 100 others, waded, tracing their path carefully, keeping to the median of the now vanished road. He reached home in 4 hours. Meanwhile, what do you think I would have done? Yes, the childhood memory kicked in, and I went about filling every bucket and pail I could find. Water had risen by another foot, and by now all our cars in the still parking were underwater. The taps ran dry by night, and for the next 5 days we lived and shared and braved all odds as a community and family of Versoville, our housing society, helping each other, sharing food and water and any other basic needs. It is also the time when I knew Mumbai was not my place. I also knew by then that the event will not be one off. And over the years, I can say sadly, I was not wrong. The pictures of 2005 or the ones 2020 are the same. If I am to review these two events, in 1977, low-tech hand pump was instrument of resilience, while in 2005, it was communication, followed by action based on the memory of past experience that defined our resilience. And this reflection brought another thought to surface. Capacity to overcome adversity is less to do with capabilities and more to do with adaptability. And so is the case with our surviving built heritage. Adapt is often used, and more so in recent years in conservation community, and has almost become a noun instead of an action verb. We have developed a neat Venn diagram to box the heritage, but let us examine from our learnings, from our own passage through life, isn't it more of a linear progression wherein inputs are periodic to ensure the continuous evolution of the cultural entity? Thus, what we receive is sum total of many interventions based on the experienced discomfort, success and failure, or identified problems, which was then resolved. The process led to modification, that then generated solution, which was then adopted by the masses to in turn become a defined practice, and we call it now as style, regional vernacular, Mughal, or what so on and so forth. When we characterize the values in 21st century of any cultural entity, they are an account of the end product, but largely they are not synthesis of its process of arrival through time. While we have been seeing us and our heritage from the lens of survival of the fittest, it occurred to me, especially in these last few months, it actually is survival of the most adaptable. The only constant in our lives is change. Managing and adapting with the changes has also been a constant. So, why are we in such an existential crisis? Analysis of human progression seems to suggest that our industrial revolution increased the rate of change with no time to reflect on the continuum of existing resources. In Indian context, post-liberation economy in the 90s ushered an era of high consumption propelled by economic interests to position India out of the developing third world nation category to the arrived developed. But what was or is the benchmark for such a notion? What are the problems that have been brilliantly resolved by the developed nations that merit reproduction? To my mind, reflecting on ushered Anthropocene era and almost 30 years of dilly-dallying on the environmental impact of high resource consumption for greater economic growth is the biggest collective failure of humans. Positioning the modern as a goal and treating the centuries-old tangible and intangible cultural continuities as ephemeral perhaps has been our most prominent error. Coming back, so what is resilience? Now, dictionary tells us resilience as a noun is the capacity to recover quickly from difficulties, toughness, Resilience as an adjective is the ability of a substance or object to spring back into shape, elasticity. Resiliently is an adverb in a way that shows the ability of being to resist being badly affected after something unpleasant such as shock, injury, etc. So our cultural collective is all of the above? Or is it something more? Can one ever go back to former state after an experience of stress? Should one? Is resilience an appropriate goal? Or can there be another system, one of cumulative resiliency, on the lines of build back better? I now examine these thoughts through my professional retrospect. Oroville was my home for almost 30 years back, for about 5 years from 1990 to 95. Here are some early pictures of Oroville and how it is now. 50 years of inception of this dream and realization through belief of many hands and minds. Some just dug holes and planted trees in initial years and then observed the torrential rains washing away the topsoil, deepening the canyons and further desertification. Check dams, bunds, lakes, these were built and revived. And after more planting, by 1990, afforestation became self-regenerating. Oroville Building Center with its Earth Division became my professional foothold, but even more valuable learnings came from exposure to living consciously. What does that actually mean? It was learning about the significance of seed banks, growing of organic food, management of fields, and mixing plant species as in permaculture, study into the plant systems for fixing nitrogen in soil or carbon monoxide in environment are just some highlights. I heard Vandana Shiva for the first time and was so impressed with the likes of her that were fighting for indigenous species of rice, neem, turmeric to remain patent free and not be appropriated for profit by the US system. Also heard Fritz of Capra and his articulation of metaphysics as a parallel to spiritual living that encouraged the humans to become aware of the theory of connectivity, the hidden linkages in our biosphere. Oroville made representation at the Rio Summit and brought back many films that aptly introduced Gaia philosophy and created ripples among us. I continue to decode all that I experienced and is a powerful lens for a worldview. The mainstream professionals considered it all a part of an obsession of a community in an experimental mode. And most dialogues continue to finish at, while it is all very nice, but how can this ever be part of real life? And in the last 2 decades, I have discovered that indeed it was very much part of daily life in this country for centuries, albeit forgotten and neglected and even abhorred in the modern era. At Amir, the concept of planning and designing with nature became tangible for me. Essentially, a dam wall spanning the 2 hills of Aravali in the northern outskirts of Amir village, designed to have rooms at a lower level for services and a pavilion to serve as a short stay lodge at the Royal Constituted Upper Sagar, and another check dam wall with a walkway created lower Sagar. The resultant reservoir and Panamiyaka Kund, a stepped well. In the valley, at the village center, are just a few of the design interventions from an era of deep understanding of topography and water connect. While restoring, we insisted on desilting the reservoirs as a component of conservation strategy and repaired the dam walls. We emptied the stepped well of all the solid waste that had collected in it over years. Another anomaly of our modern culture that worships the water and the water bodies as cultural practice and yet has no qualms in dumping waste in it. In time, post the good monsoon's rain, we were delighted to find that not only the restored 3 sites, but all of the 175 wells and bowries in the valley in and around Ambir had water in them against 26, as the case was before the conservation effort. Thus, not only did the built enables were restored, but also we had managed to recharge the water table. That in turn revived the ancient water system. As an experience, it is a powerful reminder on connectivity. And believe me, it is most rewarding and humbling to experience the ingenuity of 12th to 18th century planners and builders at such close. And this year, to raise awareness and engagement, Jaipur Virasat had commenced water walks in Amir, and I strongly recommend to all of you to be on it in your next visit, as there are some extraordinary lessons to be learned from this rain deficient region on water capturing, storing by effectively harnessing the geography and geology. One of the most significant steps India could take towards water resiliency and hence security is to take up conservation and restoring of each of the traditional water wells, lakes, and collection ponds and related systems that dot the national landscape. It, however, will have its challenge, as we found in our next project in Golcha Gardens, Jaipur. We were engaged to undertake reckonance survey of this historic property in 2014 to exactly identify all its layers, site geographic evaluation, recording and analysis of architectural character vis-a-vis periods, evolution of the site, timeline materials, mapping of existing land use, and for effective results, we took the first section being the three primary photo documentation, land survey, as-built survey, the works. The second part of the exercise was the questionnaire to identify the needs and tabulated identified vulnerability factors and primary recommendation for mitigating the same. In a way to understand which ones were urgent, so immediate, not so important, so on and so forth. Proposal design was conceptualized as a vision document to be dynamic and evolutionary in nature as a situational priority would dictate its finalization. This is just one sheet, just to give you an idea of the scope of this project. Of all of the above, most relevant for today's conversation is this slide. So to give you the location, we are looking at Transport Nagar. We are looking at unregulated residential development. We're looking at the satellite picture with the water lines. We are looking at this another, and this is the road which becomes Ghatki Guni Heritage Road. The findings are mapped, and you can also see from picture taken from top of this temple, which gives us how the water flows into this valley. Transport Nagar, a commercial district, bounds on this area. There is also informal housing which has come up here. This is the boundary which is of the property, but not with a wall. These give you the conditions that we found. So we not only limited ourselves to look at the vulnerabilities in the 12-acre property of this site, but being extended, because we learned from Amir, we extended our study right across around it. And we are glad that we did that. The unregulated development on the north end side beyond the property line is without appropriate sanitation and no allied services. The physical survey revealed sewerage-filled stagnating water. And after rains, all this water is getting collected down here. And we can imagine that there is a water channel as well. Why? Because there is a historic Bowery, which is part of the property. And earlier days, all of this water, this location is justified. But today, this is full of risks. So our mitigation strategy is we explained it to our client, to create a boundary, allow all of this water to not enter and rather go around it, away into the drain, which is on the location, and to collect the rainwater for the Bowery only within the site. The emerging theme of water as a force to reckon is not unfounded, but it is also an elemental entity whose nature is predictable, and thus traditionally solutions were aligned with its nature and not fight with it. The next case study personifies this stand. The rehabilitation of Town Hall Shimla under the aegis of Asian Development Bank funded infrastructure development project for tourism. The significance lies that heritage is now being recognized as important infrastructure, deserving investment for their conservation, for new lease of life. Of the many buildings identified, Town Hall Shimla was the first to be completed and is now awaiting reuse as a cultural resource center for Himachal Pradesh under the State Department of Culture. Primary characteristics: British colonial building 1908, north and south facade abutting the Ridge Road and the Mall Road respectively, and thus becoming a unique architectural ensemble of 2 and 3 floors. And conservation rehabilitation entails specification and methodology for conservation of exposed brickwork, repairs and cleaning ashlar, stone slate roof, lime mortar, plaster, timber works, retrofitting of services, as well as including smoke alarms, fire retarder sprinkler system, toilets, internal and external lighting. The rehabilitation of Town Hall displayed capacity building for the government and undertaking. The ingenuity and vulnerability factor of this building is in its design. Besides the blatant abuse of the building by the users, if I were to choose just one image of this factor, it is this that defined both the road level and repeated tarring, which was pouring the rainwater and the melted snow into the foundation of the town. So as a mitigation strategy, we reclaimed the original drain, pushed back and created a new retaining wall. The lining of this drain original with lead sheets and then covering it up to create an infrastructure which was planned for the original design, for the original building. Yes, we did do grouting of the foundation walls onto between the gaps between the wall as well as the drain where the gaps were to fill it. And this is how it is today. But there is another observation here. The works that have been done by the different departments are not in tune with what they are doing. If a department does a tarring, it's not really sensitive to what the infrastructure needs are. And none of the departments really speak with each other. This is a big risk for our urban heritage or for any of our cities. And there is another observation. This is a challenge in terms of getting quality in these executed works. Most surprisingly, it came from the craftsmen. The attitude for job for money was resulting in shoddy work. To bring sense of respect for the old building that they were working on, I had to remind them that while their building may be colonial, the craftsmen that had built this building in 1908 were from the region and probably their own ancestors. This sentiment did shape some change in attitude of ownership of one's work. However, I did realize that we as a nation are losing our sense of pride in our work in all spheres, and mediocrity or less is becoming norm. But there is another observation here. The works under government department tend to be shoddier than those with the private agencies like the Taj Hotels or the Oberois. One day, sipping tea with the carpenter's team, I found that the same team had worked on the Wildflower Hotel property in Kufri, and it's beautifully executed. I was even more perplexed And when I asked them why the work at town hall was less than beautiful, the glances were sheepish. I know for a fact that the money paid to them was more. Hours of work were humane, and so I came to two conclusions. That my assessment that colonial building was of less value to them, and hence shoddiness in work, was misplaced. And more importantly, public works are seen to be less valued by our building agencies. We have no sense of ownership in our collective, even though it is our money that is in play as taxpayers. This is a crisis of belief system. And this brings to another experience. India is truly diverse, also in cultural beliefs. The link between built fabric and cultural beliefs came to light to me in a very concrete form in traditional architecture of Kur. The most striking of the built fabric of Kur are the family mansions called the Ainamani. These courtyard type houses are large campus like situated strategically on high ground, often abutting the family's agricultural land, much like the Goan houses. Most of them are 300 to 400 years old and are very well preserved and looked after. The Kodavas are a small genetic group and have moved to major cities and abroad, just like many Goans, and yet to find these houses in such well kept condition intrigued me. Having witnessed the severe neglect of the similar edifices in Goa, I was perplexed and in the social history, custom of Kodavas then revealed that they worship their respective ancestors. The family houses are embodiment of the ancestors and hence revered. The northwest corner of the courtyard of the main house is adorned with a lamp that is lit 365 days a year as a symbolic reference to the ancestors. Each member of the clan, through the generation, has a place in the family home, always, no questions asked. A kind of social security, wouldn't you agree? And so most inhabited by some family member or the other. And in recent years, a caretaker is often engaged. The British tried to break the customary unity of Oka, and the landowner family unit encouraged individual land home ownership to have better control during their rule. And a few families did divide the property, but still reverence remained to the original family Aineman. All births, marriages, death ceremonies continue to be observed with the customary visit and ritualistic celebrations to it. Thus, in this case, it is the belief system that has emerged as the force de resistance and ensures continuum of a cultural entity, even though the building in itself is also being adapted for contemporary living in terms of services, but not as much in terms of spaces. And this brings to the next case study, which is an old Goan house. Goa experiences 3 meters of average rainfall a year, and mostly in the 4 months of monsoons. Most Goan homes have wells. All wells have water. And so did this Casa Place, one of our project site. However, when we studied the surroundings of the site, my alarm bells rang loud. The boundary wall separating the site and the informal housing at the north end showed severe dampness, and also the area had foul smell. So we got the well water tested and not surprisingly found dangerous bacteria E. coli in it, and thus not fit for consumption. And this too is a major curse. The houses are built spending an enormous amount, and when it comes to services like septic tank, cost cutting comes in, and only soak pit is employed by the fly-by-night contractors of these houses. So while we informed our client, we also took steps to still maintain the well and put it to good use. The backwash of the swimming pool was routed to the well, and in turn, the well water was designed to be used for irrigation of the expansive grounds, front part, which was designed as a mini golf practice landscape, and the rest is a kitchen garden, is being maintained without the guilt of wasting water. Over the 3 years, the alum used in swimming pool water has in turn improved the quality of the well water. While the concrete underground foundation for the rebuilt boundary wall too seems to have checked the wastewater ingress. This should have been a concern of entire locality of this village, and mitigating strategy in form of a community septic tank for those housing should have been pursued by the panchayat. I also learned that the politics under 73rd Amendment to Constitution, which places planning responsibility of a village onto panchayat and participatory process through Gram Sabha, the effectivity of it is directly proportional to the education level of the elected. In the last few months, it's become evident that one of the biggest gaps in governance and thus the foundation of resilience as a nation is lack of education amongst our governing bodies. We will leave it at that for now, but it is very evident that unless educated professionals like engineers, doctors, environmentalists, planners, and architects take up not only the government jobs, but become effective voices as civic society, the future in this era of climate-induced crisis is precarious. To conclude, be it Roorkee, Mumbai, Chennai, or Jaipur, this year or Hyderabad last month, urban floods are symptomatic of planning blight, failure of governance, and privatization of public lands. Our historic cities inform us of symbiotic relationship between people and nature in pre-industrial era. Post-industrial revolution, green revolution, information technology revolution have cumulatively generated a development model of people over nature for maximum financial gains. And now, nature is exhausted of its inherent power to renew itself. Air, water, land of planet Earth are saturated with man-made pollutants. It is the last hour, or so to speak, for humans to adapt their living and revive the symbiotic relationship with our planet and its life cycle. Myriad of solutions exist. Same IT has connected us across the planet and beyond to have the information in real time and also the various research and outcomes. Auroville is a living example of nature and people's synergy. We can still redeem ourselves, but even this window of mindful existence to walk lightly on planet Earth is closing fast. Soon it may not matter if we continue with our early 21st century acquired throwaway culture and chalta hai attitude. We have the knowledge, we have the structure, we have the resources. All that is missing is the will of the people because this adaptation will have to be done by the people. And even despite the governments, irrespective of nationality, caste, class, faith, and the politics, for all life and living beings. To now survive as a human race, it is time for regenerative development strategies because in this resides resilience. The art of regenerative is really the art of developing strategies, I believe. The relationship between caretaking and commodification is explicitly balanced. Land, rivers, fields, and forests are all valuable resources and not commodities. Citizens in a democracy are not subjects to be ruled, but co-participant in shaping the future of this country. And we professionals are citizens first and need to take on more ownership. Thank you.
Thank you so much, ma'am, for the insightful information on resilience and walking us through the timeline and your personal experience on different projects. I have few questions, rather discussion points with you. First is when you showed the project of Shimla and how the artisans, the same artisans who had worked on a different project, they had put in their efforts, and then the same people on a different project were not putting in effort. Is it something you come across, in most of the projects, or it was a particular case of Shimla project?
I have come across, I mean, this has changed. My experience in Jaipur Amir, which was also the government project, was different. That's why it was, I think, in like that is 2001 till 2004. And Shimla is like 2016. So in a decade, I think we have lost a lot more of our own pride in our own work. There is a definite decline. Also, it's almost like this is something very strange. No, people don't realize that when we are doing public works, it is for the public means it is for ourselves, right? And we are paying for it. What is government money? We have, so who has failed in translating this relationship, that when we do it for ourselves, like a private client or something, then we associate this face or the name, as the owner who's paying the money. And when we are paying for ourselves, we don't, I mean, you look around, yeah, I mean, I think it's pretty common that look at the drains, look at the the kind of, and my God, I mean, what is going on with the smart city projects, the way execution is taking place? I mean, this money, ADB funded, it doesn't mean ADB is giving you money to do it. No, it's actually a loan, and we have to pay it back. So maybe we are also not aware that the professionals need to supervise better and say that you're paying for it, better do it better. That's my.
So the response from the people who are associated with the project is also very important, not just the aspect of the project. Like till now in the discussion, we talked about the structure, we talked about different elements of structure. But here in this particular discussion, we are also talking about the people involved in the structure and their response.
Absolutely. And I think this is the foundation. And maybe we are, I respect every speaker's point of view. And this is for students, but it's also a foundation where we have to wake up to the realities. We can't kid glove the next generation because the situation is pretty grim. And if COVID hasn't told us about that climate crisis, we still have gray skies in Goa, and this is end of October. There's nothing romantic about it. It's here, and how, as Rohit said, I mean, he was being gentle about it, and I'm just being very clear-headed about it, that we have to wake up to the situation, and wherever we are standing, in whichever capacity we are looking at it, we need to do better.
Yes, yes, we need to do better. And a collaborative approach, as you said, a participatory project involving the community living around and involving different professionals, right from engineers, architects, and different
And
professionals.
despite,
Yeah,
absolutely, and despite of the government, and it's really time. I mean, if we can, as Rohit said, I think I have done the same too, is to move out of this closed circuit of monuments and of, but actually looking at the ability. And also I worked 10 years as a sustainability and an architect, and built buildings, and then got into conservation. So you have a different approach to it, because all of it needs a continuity. We can learn a lot. I came into this because you can learn a lot from a cultural continuum, yeah, and apply the synthesis, how to carry those values forward. It's very important. And those values are to do with commitment. I mean, whether it's a belief system or whether it's the way it's the place. I mean, why would the Royals, Jaipur, Amer, whole of Rajasthan and Jodhpur, the number of stepped well, Delhi, all of it. And today we can't necessarily revive all of them. We have created, I mean, who's creating that mark? 10 days it took us to empty that stepped well. 10 days. That much of muck was in it. And why? Because people were praying. I mean, we pray to water for all rituals. There is never a puja without water. Or any, you can take any religion, there is water involved. And how do we deal with it? We keep mucking it. Look at our rivers, all of them are polluted. Who's actually responsible? We can't go on saying the government should clean it. Who's making it a muck? People. So if we stop, we have to take that responsibility, and we have to say it the way it is, that we are the number of people in the government are much less than the citizens.
True.
So I guess citizens have to take their responsibility um, immediately and most sincerely.
Like Rohit sir had shown in the graph, that if we, if we even continue the way we are going to create a large impact. But if we kind of reduce these habits of us as humans, what we are creating around, we may reduce the effects in future.
I mean, if you think about it, in 100 years, the Industrial Revolution, the Green Revolution, and all of it, and it's all available on different movies as well. Now you can actually access the issues very. Kiss the Ground is, I would strongly recommend everyone to see it to understand what we mean by Green Revolution and why it's not been. We need to reverse. It's also about that it took only 100 years for consumption to do what, undo the 5,000 years of continuum and where we are. And if we in just 20 years of India, I remember it, and I think my age group people would remember this last 2 decades, the way the consumption has gone up and the race only for money and loss of value, loss of friendship, loss of families, only for money. I mean, this is like a perpetual growth, which is just not possible. It's not. So,
Also, if any of the participants have any question or doubts or want to raise a discussion, please write in the chat box. And the ones who are seeing our live stream, you can comment in the comment section. Ma'am, I have one more thing, which, we had this discussion earlier too, while we were talking about the topic or the title of your presentation, that how the way these monuments and historic structures have stood the test of time through years, and why the modern technology or the modern houses are not implementing few things or few characters from those buildings.
yeah, and that's what, we have boxed. And I thought that was very important to, on reflecting after you called me and that I would be making this presentation, I realized that actually it's the process which we are not documenting. We are not engaging, and funnily enough, Rohit also mentioned about it. So there is a lot of echo, no, in terms of that, to box it and keep it aside and to look at it as something that is precious jewel and take it out, that's where I think we in India and Asia, I would say, have the ability, because we also have intangible cultural heritage of continuing with this knowledge system. It is declining. I could see it from 2001 to 2016. There is a gap, but there is also, while the government agencies are getting better at understanding conservation, our craftspeople are losing because, of course, generations, no? So in 5 years' time, generation gaps will come in. But that is why it is also important for us to look at the processes and look at the life cycles of materials. Like lime, for instance, is cradle to cradle. What a wonderful material. Why shouldn't it be used in contemporary construction? Why can't it be the basis of plaster, when actually 90% of it is what cement is, no? So this getting to uh, unpack the traditional materials, why they have lasted, and how we can contemporize. And that's why I selected a few examples where the continuity of thought process as well as continuity of the place, while mitigating the challenges which are being seen. I have tried to I tried to choose those, and also to highlight that risk factors and our vulnerability are ingrained as much from external sources as the big events or small, but from ourselves, within ourselves, as to how we take what stance we have as a professional.
Yeah. Interestingly, in one of your case studies of Amir, when you showed about the water levels and how to retrieve it, So we have, I have been relating many things with Ahmedabad case study. So we have these takas in Ahmedabad, and they all were functional. But then you know put up the new board system, and kind of the original authentic system gets dysfunctional, and it's covered up. So same things are happening with stepwells or kunds. What is your take on this entire concept of
If we don't do
modernizing?
it, yeah, so it's really like a good news is that like from Tamil Nadu, which was also, you know what, it's like collecting. Water is a renewable resource, firstly. Yeah, we do get monsoons, we our rivers, our lakes, our ponds, and it is self renewal, self correcting system. If we collect it and then deposit it, because it will happen by nature, into the water table, safely deposit it, we can withdraw. Now, if we keep withdrawing, there's not going to be any deposit. No, it's just like a bank. You have to make the deposit. That's one part of it. The second part is, see, when the taps hand pump came, that no, the wells were forgotten. Then the tap came and the hand pump was forgotten. And then now we think that the water comes through taps. How it comes, from where it comes, what kind of money we are paying, and then with various kind of hazards coming in, water channels can change. Yeah, until unless locally we have to capture the water because it is there. We have the tools now to look at the GIS mapping. We have the tools to see what are the water channels now. Why did Jaipur this year have such massive floods only in the walled city? Because there was a whole system of open areas which were used as lake and capturing of rainwater because it's on the shadow of Aravallis. And then you start building houses. So again, it comes to, in a way, we can call it urban, but who Jaipur walled city is not about urban, it's about greed. No, how many houses does a human being need? Three, four, five flats. I mean, I'm living in Goa, and it's like 60% of flats which have already existing are actually lying vacant. We have a housing crisis all over because people can't afford those flats, and those people who have bought those flats have so many houses, they just want to rent it out or park their money. Do you think all these are all social risks factors which are actually putting a lot of pressure on all of these elements, whether it's water, whether it's land, whether it's food, whether it's all of it is connected? And that's why I tried to highlight also on connectivity, our footprint. So you can't look in isolation only how to channelize water and recharge it. Yes, but we also have to see what are the elements and where. So human being has to change. Our conscious living has to come in. It has to start from there. Solution for all other problems are existing except for how do we make a human being think differently, take charge of it, look into it, and reduce their footprint. I can't
Definitely.
stress that enough. I think that's it. There is no other solution, no moving away from it.
Mm.
Human being has to adapt according to.
I'm sure everyone agrees on this. All the participants do agree on this. Okay, thank you so much, ma'am. It was a very interesting session,
I
and
hope the voice and presentation signal was not too weak. One is never sure, and it was
no, it
so
was
it was
audible.
okay. Yeah.
It was audible. Thank you
Okay.
so much. So now
Great.
we'll move towards the concluding remarks. For concluding remarks, we have our in-house person, Ashna Patel. Ashna is an architect and academia. She works in academia. She has completed her graduation from CEFT University and holds a master's degree in international architectural regeneration and development from Oxford Brookes University, UK. She has been associated with the Masters in Conservation and Regeneration program at CEPT University as visiting faculty since 2018 and has been part of various design studios and architectural history and theory courses at the School of Environmental Design and Architecture at Navrachna University, Baroda. She is also a practicing architect and partner at Fifth Column, a Baroda-based design studio. Ashna, over to you.
Thank you, Nigar. Thank you for the introduction. I feel extremely privileged to be speaking, privileged and nervous to be speaking among such senior and expert professionals from the field. I will do my best to outline the key points that were discussed today, but do pardon me if there are any errors from my side. So first and foremost, I would like to thank all the speakers for presenting their work so comprehensively and sharing their experiences and perspectives on risk assessment of cultural heritage. I think it has reminded us all and made us more aware of the immense potential of risk assessment and risk reduction and disaster mitigation. So I think all four speakers have stressed on the importance of looking at risks in amalgamation and looking at the impacts of these risks on various other aspects of our lives or on the built cultural heritage at large. So we saw a wide range of tools for monitoring, assessment, prioritizing interventions, mitigations, etc. The very extensive keynote presentation by Dr. Ferreira highlighted the importance of working towards reducing vulnerability in order to mitigate the impacts of the hazard and the level of exposure to it. So it was very interesting to learn about these various tools and techniques that are used in order to not only determine the vulnerability index in buildings, but also to carry forward these studies to estimating probable levels of damage and gaining knowledge of other impending dangers and likely repercussions, such as collapsing, casualties, homelessness, etc. So it was very enriching in that sense. Then talking about the presentation made by Dr. Menon, it looked at risk assessment as a crucial part of a larger exercise of disaster mitigation, along with various other peacetime exercises that he discussed, which contribute towards a more preventive approach towards conservation, or adopting a more preventive approach towards conservation. And the discussion, particularly interesting, was the discussion on the various phases that are involved in disaster mitigation and management. And as he put it very rightly, all these phases have to function like a well-oiled machine. So it was very interesting to know the details of how it all works. Two very relevant and but varied approaches were presented through the two case studies that were talked about. One as an exercise in multi-hazard risk assessment at the level of an urban cluster or a population of buildings, which showed us how the magnitude of all these risks need to be evaluated in combination, and throwing light on various methods. And the other one was throwing light on various methods to approach buildings as individual entities. I felt that it was very important to, a couple of important points that were made by the end of it was stressing on the importance of seismic improvement interventions, as well as critically looking at vernacular traditional designs in order to make them better through new detailing. So I think it was advocating a more open approach towards making these interventions. The closing case, the case with which he closed was particularly interesting. The case of Bhaktapur Darbar Square, which further advocated the importance of disaster mitigation through repair and retrofit. Both the first two presentations were very rich in terms of representations of analysis of the various studies that were through the various studies that came out, and it gave a very comprehensive indication of how these processes are actually carried out on ground, and how important it is to be very systematic and methodical in your approach. moving on to Dr. Jigyasu's presentation, which also echoed some of the points made by the previous speakers. It interestingly began with perspectives on built heritage as a system and its evolving nature, which is a result of its dynamic interaction between people and the environment, and thus, leading it to be a part of an ever-changing context. And I thought it was very important for all of us to be to recognize this, or rather to be reminded of this point. Another very interesting viewpoint which was shared was on what risk actually is and what it comprises of, its various levels, time perspectives, and also more importantly highlighting its relative nature, which ultimately leads us or facilitates the process of prioritization and appropriate action. So yeah, looking at risk from probability, from the probability and consequence perspective. Another important point was again, which was also stressed by the other speakers, was to look at or acknowledge the connection between multiple hazards or multiple risks, acknowledging the connection between momentary and catastrophic disasters and the natural processes which have more slow and progressive effects on the built cultural heritage. Yeah, so Dr. Jigyasu left us with some very relevant questions regarding long-term impacts of risk factors on values, levels of risk analysis, balancing maximization and optimization, and so on. Talking about, leaving us with something to reflect on, Poonam ma'am's presentation was very insightful and it gave us a lot to internalize. A very interesting account on the idea of resilience, different from what we normally see, and looking at it from multiple but related viewpoints. So talking about achieving resilience or building resilience through some very inspiring projects. Also, it was very interesting to know from her on-ground experience the various factors that affect or create gaps in the process of achieving resilience, such as governance, whether it's due to conflict of interest, lack of awareness, lack of education, and the whole presentation or the whole discussion made us realize the importance of being more aware. We think that, we know these things, but I think all of us need a certain reminder, after a point where, then we tend to forget about these things. And, we have to remember that it's more about pushing our personal and collaborative capacities and taking responsibility rather than waiting for some institutional body or governing body to take responsibility, and being committed to carrying forward these values to future generations. So particularly interesting was the focus on regenerative development strategies and looking at nature as a resource and not as a commodity. So yeah, it gave us a lot to think about, and it emphasized the point of survival of the most adaptable rather than survival of the fittest. So on that note, I would like to thank everyone, thank the organizing team from CHC and MCR, Nigar, Sarvesh, Zias, and Juhi from CHC and MCR, and Firak, Shivangi, Shaili, and Shubham from CRDF for making this webinar possible and ensuring that it gets carried out very smoothly and efficiently. Nigar, thank you once again for moderating the session so wonderfully, so beautifully. And a big thank you to all attendees for your enthusiastic participation and for raising such pertinent questions to enrich the discussion. We look forward to having more such webinars in the near future, and we hope to see all of you there as well. So thank you.
Thank you, Ashna, for your concluding remarks. Before concluding the entire session, I would like all the participants and speakers to please turn on your videos so that we can have a picture together as a memory.
And I'll take this opportunity to say bye, and it was lovely to share this platform with Rohit, Arun, and Tiago. Lovely. It's really nice to hear you and be with you on this. Thanks, Nigar and CRT.
Same here. It was great. Great to see all of you.
Yeah, thank you very much for the invitation. It was a great afternoon for you guys, morning for me. It was amazing. So thank you very much.
Yeah, I also want to join everyone. So thank you all. Thank you very much. Very nice.
Yeah, while we are waiting, no?
Okay, Zia, is the picture done? Zia, can you hear me? Is the picture done?
It was a thumbs up.
Gave a thumbs up.
Okay.
Yeah.
Thank you all, for your valuable time and well-curated presentations, and all the participants for showing interest and sticking through the entire session. Thank you, everyone. Thank you so much.
Thank you.
Bye-bye.
Very nice summing up, Ashna. My compliments to you. It was really nicely done. You did very well.
Thank you, ma'am.
Yeah.
Thank you so much, ma'am. Means a lot.
All right. Cheers.
Thank you.
Enjoy.
Bye.
Enjoy. Bye.
Bye.
See many of you at the special session of the AGM tomorrow.
I know, Arun. See you soon. You couldn't miss it, right? Okay.
Bye.
Bye. Take care, everyone. Lots of love. Bye.